Hello, if you're a Power BI developer and you're looking to understand the world of Microsoft Fabric, then this video is for you. This video is 3 hours long of back-to-back tutorials. We're going to step through a lot of the major decisions that you're going to have to make when you're transitioning from the world of Power BI to the world of Microsoft Fabric. So we're going to be going through how to set up your environment, how to design capacities and workspaces, how to give access and manage security to all of these different items in Fabric. How do we get data into Fabric? How do we store data in Fabric? How do we choose between a lakehouse, data warehouse, KQL database? Then we're going to look at how do we actually build semantic models? How do we build Power BI models on top of data in Fabric? How do we validate these solutions? Because that's one of the biggest benefits for me, at least, in transitioning to the world of Fabric. We can build really high quality data pipelines to make sure that your data that you're serving and the visualizations that you're presented to your users can be trusted. Towards the end of the video, we're going to go through 36 questions that you need to ask yourself when you're designing and building end-to-end solutions in Microsoft Fabric. And finally, I've got a bit of career advice at the end of the video for you personally. What should you think about if you're considering a career change to work more in Microsoft Fabric? So considering all of that, this video offers a really good introduction for you to really understand the world of Fabric in a bit more detail so that you can make good decisions for your company and for your career. If you're new to the channel, my name's Will and I'm a full-time Fabric trainer. I help you understand the world of Microsoft Fabric, and I do that through these videos on this channel and also in my community on School. So as well as the video content that you see on YouTube here, it's a really good idea to follow the link in the description, because for a lot of the tutorials that you're going to see in this video, the related documents and notebooks and files, they're all saved in this School community. So make sure as you're following along this course, all of the stuff that you need to download is in this School community, so make sure you join there as well. Thank you very much for watching. If you do find this video valuable, please let me know in the comments, share it with anyone in your organization that you also think might find it valuable. Thank you very much. I hope you enjoy the course. Hey everyone, I'm starting a brand new series, and this is the first video in that series. I'm going to be walking you through how to transition successfully from the world of Power BI to the world of Microsoft Fabric. I know from speaking to a lot of you out there, a lot of you are Power BI developers, and a lot of you have seen the kind of the innovation and the new tools available to you in Fabric now. And you want to know what are the best strategies and what do we need to consider to make that migration really successful. When I talk about that migration, this is really what I'm talking about, right? So you're probably familiar, you're probably working towards what I would call a Power BI centric architecture currently. So you've got some data sources, and each of these data sources might be either going into a Dataflow, so a Power BI traditional data flow, or you might just be loading it straight into your Power Query engine in Power BI Desktop. And this is what I would call Power BI centric architecture. And what we can move to now to start leveraging all of that good stuff that Fabric provides us is what we call a Fabric centric architecture, right? So instead of ingesting our data straight into Power Query in our Power BI data model, instead now we're going to be ingesting into Fabric, and we're going to be storing that data in one of the data stores available to us in Fabric. So either a lakehouse or a data warehouse or a KQL database. And then we can read that data into our Power BI reports from Fabric. So this is what we call the Fabric centric architecture. And it looks like quite a simple change, right? But actually there's so many things that we need to consider of how we set up Fabric. And there's lots of different strategies. So depending on your requirements here, you might have got quite stuck, right? There's so much choice, and a lot of these concepts might be new to you. So in this video and in this series, I'm going to be filming 7 or 8 different videos that walk through some of the key decision points that I think you're going to face in the future when you're migrating from this Power BI centric architecture to a Fabric architecture. And I know these are important because I asked you in my community. So if you haven't joined our community yet on School, then I would definitely recommend that you do that. And I asked people in our community, what's the biggest unknown in Fabric? What are you currently struggling with? What would you like to know more about? And we've had a really good discussion. Lots of people are getting stuck in, but there's a lot of recurring themes, and these recurring themes are exactly what I want to produce videos on in this series. So some of the themes that I've noticed is this one's about getting data from AWS. So how do we get data into Fabric is a common theme. How do we choose the right data store? So is it a lakehouse? Is it a warehouse? What are the differences here? What are the nuances between the different data stores? When do we choose which one, depending on our requirements? There's also, Kojo here has asked about the medallion architecture. So this is a lakehouse architecture that a lot of people are applying in Fabric. So we'll talk about the benefits of that, the drawbacks of that, when to use it, when not to use it, and things to consider there. Also got a question around Fabric shortcuts. So when do we choose whether we ingest data or create a shortcut to an external data source? So perhaps you've got data already in Azure Data Lake storage or even in Amazon S3 buckets. So these are the kind of things that lots of people are asking me about in our community. Another thing that we talk about or has been asked about is workspace organization, right? And it's linked to the medallion architecture or whichever architecture you choose, because workspaces are so important, more important than they are in Power BI, I would argue. Because in Power BI, it's just kind of organizing where your data sets or your semantic models and your reports live. In Fabric, they have some constraints around, because we're kind of moving data between different workspaces sometimes or creating shortcuts between these things. There are constraints around how people can access different data sets. So depending on your kind of access control requirements is going to inform your workspace strategy. So I get lots of questions about workspaces as well. Here again, we're talking about Data Factory and Lakehouse and choosing the right thing. So just to flick back to this diagram here, and in case you're not 100% sold on the idea that this is actually a better way of working for most people, not for everyone, but for most people, why do we think this is a good idea, the Fabric-centric approach? Well, number one, I would say data governance becomes a lot more simple. And here I'm talking about access to data, documenting your data. All of these things comes with Fabric, and it's very difficult to do that kind of thing in a kind of Power BI world. Also enables or makes self-service analytics a lot simpler to implement, I would argue. Now, one of the biggest benefits that I see in this kind of Fabric-centric architecture is around data quality, right? Because in our traditional system, our data sources are being ingested directly into a Dataflow or Power BI. And this is really flimsy, right? This is very prone to error because anyone that's worked in data analytics and Power BI for a while, you'll know that data sources change, the data structure change, data types change. The quality of the data that comes from these different sources generally changes over time. And there's no protection against those changes in this Power BI centric architecture, right? Or at least it's very difficult to add in kind of data quality checks and data validation checks. And what does that lead to? Well, it leads to your users seeing erroneous data, errors, things, or your Power BI model fails to refresh if there's errors kind of in the structure of the data that changes. All these things make users lose trust in your reporting and your dashboards. So in Fabric, one of the key benefits that I see anyway is we can really get a grip on building a robust system for managing data quality. And the final one that I'd mention here is around data science, AI and ML, machine learning. So Fabric is marketed as the data platform for the era of AI. And if you're still using your traditional architecture for Power BI, it's very difficult really to integrate machine learning, AI, data science stuff on top of that Power BI centric architecture. So when we move to Fabric, the Fabric centric architecture, the whole reason Fabric has been built to make your data sets in your organization a lot more accessible for things like training machine learning models, letting your data scientists analyze your data kind of a lot more easily. And there's the oncoming kind of LLM, large language model revolution, I would say, Copilot integration. All of these things are basically making it as easy as possible to expose your data to large language models, generative models that are going to basically try and drive more business value for your business. So there's some of the three good reasons, but how? How do we do this bit in the middle? And obviously there's no right or wrong answer here. There's just lots of strategies and considerations. So here's what's coming up in the next 7 or 8 videos. There might be a few more, but I planned for about 7 or 8 at the moment of some of the things that I think are the most important things to get right when we're transitioning from Power BI into Fabric. So the first one I want to mention is around how do we organize our workspaces, right? So this is probably one of the first things you're going to think about if you've just set up a new Fabric tenant and you're kind of responsible for your organizational strategy in this. What are some of the strategies that we can implement for workspaces to make sure that everyone has access to the items that they need and they're structured in a good way? And these can be controlled at different granularities, right? So we can give access to people at the workspace level, at the item level. So by item level, I mean like at the data warehouse level. So giving someone access to the data warehouse, and also at the objects level. And by that, I mean, for example, a table in a data warehouse, and at the row level. So we can do all of these different things, and we'll talk about how to combine these different things depending on your requirements. Now at the item level is quite interesting because different items, so for example, a data warehouse and a lakehouse actually have different ways of configuring their access, right, in Microsoft Fabric currently. So there are a few nuances between the different items that you need to understand if you're going to be implementing your strategy in your organization. So we'll go through those in the first video. Next, we're going to be looking at data access, and these follow a bit of a chronological order that you might notice, kind of mimicking how you would approach this in your organization. So for data access, what we mean really is how are we getting access to data? Okay, so generally data isn't generated in Fabric. We have to bring it in somehow so that we can do stuff with it. And there's 3 main ways that we can do that. There's ingestion. So data ingestion is where we copy data from outside of Fabric and we bring it in. That could be either through one of the connectors or via an API, some other method. They're probably the only 2. Database mirroring is a fairly new feature in Fabric that basically allows us to mirror the contents of an Azure SQL database or a Cosmos DB database. And it basically creates a replica in your Fabric environment. And it manages all of the creates, updates, and deletes kind of in near real time. So that's another option that we need to be aware of, at least, and think about different strategies for that. Then we'll look at shortcuts as well, because shortcuts are a very important part in Fabric. And that's where we're not actually physically bringing data in to Fabric. We're just creating a reference or an external shortcut to data, for example, that lives in Azure Data Lake Storage and also in Amazon S3 as well. And then there's some kind of edge cases and maybe not edge cases, but other things to consider, like is the data in AWS? Is it on premise? Do I need to create a gateway? All these things are important to understand when you're planning out this migration. So the 3rd video in the series, or the 4th video if you include this one, then we're going to look at data ingestion, right? So if you've chosen to ingest some data here, well, actually there's 3 main ways that we can choose of how to do that. Either you can use a data pipeline or a Dataflow or a Fabric notebook. And from what I've been seeing, a lot of people sometimes get these confused and they don't fully understand the capabilities of each of these tools and when to use which one. So, and it might be a combination of all 3 in some instances, but each of these have positives and negatives and things you can do and things you can't do. So we'll be looking at what those are and when to choose which one. Now, the next one in our list is a very important one, which is around, okay, so we've ingested some data, but where do we actually store this data? What are the different architectural patterns that we can apply? And specifically, which of the kind of data stores in Fabric should we use based on the requirements that we have as a business? As I've mentioned previously, there is the lakehouse, the data warehouse, and the KQL database. And each of these, again, have different personalities, different things you can do with them, different things you can't do with them, right? So we're going to look at what those things are and then help you decide which one is best for your specific use case in your organization. Here, we'll also look at kind of data architectures in general. So this is where we'll bring in the medallion architecture concept and have a look at that and how to apply it in Fabric. And then we'll move on to my favorite topic, which is data quality. So once we've got our architecture and we've chosen our different data stores that we might need for our architecture, and we've kind of ingested some data into these data stores, then we're going to look at how do we ensure data quality. right? Because I've said previously that one of the main benefits, at least for me anyway, of Fabric is that we have the opportunity to build robust analytics systems where users can finally trust the data that's being presented to them. And you can sleep a lot better at night because you know that each stage in your processing pipeline has been validated. So I'm going to be talking you through how we can apply end-to-end data validation right across the data architecture and the data processing pipelines that you create in Fabric. So we'll be looking at what you should be validating, when you should be validating it, why you should be validating it, and how you should be validating it, right? For each of those different, what I would call like validation checkpoints along the data processing journey. So that is going to be a very good one. And then we're going to be looking at, okay, so all of our data is in Fabric. How do I connect to that data in Fabric via Power BI? And here you might have heard of Direct Lake. There's a few new options available to you over and above what you might be familiar with import mode and direct query. Now we have a few different options that are going to help you get data into your Power BI report so that you can do your data modeling in there and kind of build your reports on top of data in Fabric. So we'll be going through what that looks like in that video. Then to finish things off, I'm going to be doing kind of like an end-to-end migration project, right? So we're going to be looking at each of these and we're going to be using real-world data and we're going to be setting up some workspaces, choosing a strategy for data access, choosing data ingestion, and I'm going to be talking you through my thought process all the way through so that you understand why I think a certain architecture or a certain ingestion pattern might be best for this data set or for this problem. So that's going to be the end-to-end migration project done here. And that might be quite a long video, but I think it'd be a lot of value in there just to see how all these things connect together. So that's what I've got in store for this series. I hope you like the sound of that. Hopefully we can tick off some of these really big decision points that people are asking me about. And I'm sure there's hundreds of thousands of people out there with similar question marks around these things. So I want to spend a bit of time just talking about each of these in detail. So if that sounds interesting to you, make sure you're subscribed and make sure you click on the next video, which will be workspaces and access control. I'll see you there. Setting up your workspaces and controlling access to Microsoft Fabric is one of the most important factors to get right when you're transitioning from the world of Power BI to the world of Fabric. And it's something that I see people make a lot of mistakes in. They rush in, they set up their environment very quickly, and then they spend a lot of time trying to make it work for them. And this can cost a lot of money and it can lose business confidence when you're migrating. And there's lots of things that can go wrong here. So probably a better approach is just to take a step back, try and understand what some of the most common mistakes that people make are, understand the best practices, understand some of the limitations of some of the tools in Fabric that we need to bear in mind when we're creating a strategy for setting up our Fabric environment. So in this video, I'm going to walk through what I think are 7 of the most common mistakes that I see people making when they're setting up a new Fabric environment and how you can avoid these mistakes. And this video is part 2 in a 9-part series that I'm doing on this channel, really to help you transition from the world of Power BI to the world of Microsoft Fabric. So if that's a journey that you're going on or you're about to go on in the future, then make sure you're subscribed to the channel because there'll be lots more videos coming very shortly. Let's jump into it. The general structure of a Fabric environment can be drawn like this in a bit of a hierarchy. And in this video, we'll be looking at capacities, workspaces, and items within workspaces, and how to set up each of these for success. And normally there'll be 1 tenant per organization, although some can have multiple tenants, but most organizations will have just 1. And in that tenant, you can provision 1 or more capacities. And a capacity is a distinct pool of resources allocated to Microsoft Fabric, or to Power BI in the case of a Power BI capacity. And you can purchase pay-as-you-go Fabric capacities in the Microsoft Azure portal. But how many capacities will you need as an organization? This is one of the first big decisions that you're going to make when entering the world of Fabric. And it's where a lot of companies make their first mistake, which is provisioning too many or too few capacities for their requirements. So how many capacities should you purchase? Well, in an ideal world, you'd only need 1 capacity, because that's much easier to manage. There's a lot less administration that needs to be done. But there's a few common situations that mean that you might have to buy and maintain multiple capacities. The first one being to comply with data residency regulations, such as GDPR, that state that you have to store and process data within a specific geography. So in Fabric, when you provision a capacity, you do so in a specific region of the world, which defines where the data is stored. So to comply with these regulations, you'll need different capacities in different regions. Reason 2 is to align with existing organizational cost centers. So in some organizations, billing and budgets are managed through cost centers, which might align to specific departments within an organization. So you might have an IT cost center, marketing cost center, and they might want to create one capacity for each cost center to make billing easier and to align it with existing profit and loss cost centers. And it makes it easier to attribute what's being used in Fabric by which department. Reason 3 is that you might want to split capacities based on the type of workload. So a capacity has a set amount of resource, and if either your data processing is very intensive, so you've got a lot of data engineering, or you're doing lots of machine learning training, for example, or you've got a lot of existing Power BI reports that have quite a stringent refresh schedule, lots of read operations, and you want to make sure that your Power BI consumers are getting a good experience, then you might want to split these kind of workloads out into different capacities. Moving on to number 2, and in a capacity, you can have more than one workspace. So now we're going to be talking about workspaces. And a workspace is a place you can create Fabric items like a data warehouse, a data pipeline, and generally collaborate with your colleagues on new data infrastructure and data projects. Now at the workspace level, this is also the main way we can give access to people or groups in Fabric. But again, how many workspaces do you need? That can be quite a complex question to answer, and there's a ton of different strategies for workspaces. So you might have different workspaces for different departments, if you're working towards more of a data mesh architecture, or you could have different workspaces for different layers in a medallion architecture, for example. Plus, you might have duplications of each workspace for development, testing, production. You can quickly see how the number of workspaces can quickly add up if you're not intentional with your workspace design. Now, a common mistake I see is organizations designing too many workspaces. And it's difficult to say how many is too many because every organization is different. But if you're suffering from any of the following, you probably have too many. So data is stored across so many different workspaces that it's difficult to communicate and understand the end-to-end data processing workflow in your organization. Or if the administration of these workspaces becomes an unmanageable burden, or if the user experience is really poor, and people are being granted to hundreds of workspaces and they can't make sense of what's happening where, it's impossible to find the Fabric items that you need. So what can you do to reduce the number of workspaces? Well, 3 things for starters. One idea is to align your workspaces to personas in your data team. For example, creating a workspace specifically for data engineering items. Then we can add data engineers, that persona, into this workspace to take ownership of these items. Similarly, you might have a data science workspace that contains all of your data science items. And again, the data science teams are the main kind of owners of that workspace. Secondly, a good way of reducing the number of workspaces you provision is to name your Fabric items using a naming convention. Now, you could leverage this strategy for differentiating between dev, test, and prod data warehouses, for example, in the same workspace, removing the need to have 3 times the number of workspaces for dev, test, and prod workloads. And thirdly, it's important to understand the difference between workspace level sharing and item level sharing. And we can use these 2 in combination to try and cut down on the number of workspaces you need. For example, you might not need a separate workspace just to host the gold layer of a medallion architecture, for example. And that could be a data warehouse that you're surfacing for people using Power BI. Instead, if we understand about item level sharing, we can see that there is actually an option for sharing data sets just for consumption of Power BI reports, for example. And we'll go into item level sharing in more detail later. Next up, we've got an absolute classic. It was around in the Power BI days, and it's just as relevant today in Fabric. Now, we've all got that email or Teams message from someone saying, oh, I've just joined the data engineering team, for example. Please, can you add me into the data warehouse? So either you share the data warehouse or the workspace in general with that user. Can you spot the problem here? So if you're adding individuals to a workspace or sharing a specific Fabric item with an individual, things get really complicated and difficult to manage quite quickly. Now, a much better solution is to create either Entra ID security groups or Microsoft 365 groups, both of which you can do in the Azure portal under Entra ID. Then you can give access to the group to the workspace or the individual items. So you're only ever sharing stuff with groups. And then when a new person joins, you can just add the person into the group rather than sharing the individual items and the workspace with that individual. And if you want to do a bit of spring cleaning of your workspaces to try and understand where individuals have been added to groups, you can either do that through the UI using Manage Access, or you can also do it via the API using these endpoints here. So you created some groups and you want to add a group to a workspace. You'll notice that at the workspace level, there are 4 roles you can assign. Now, a key mistake that people make here is not fully understanding what each role means in general, but also what each role means for specific item types in your workspace. So what can a viewer do with a data warehouse, for example? If you review the documentation, you'll find this quite helpful chart that shows 4 roles: admin, member, contributor, and viewer. Then down the page, they list a number of actions that the user or group can take with that role. Now, whilst this visualization is okay, I think it's still pretty difficult to interpret. So instead, what I've done is I've taken the same information, but I've split it down to make it much more explicit for each Fabric item. Now, some of them I have grouped if they have exactly the same permissions profile, and we'll explore that in a bit more detail. But when we visualize it like this, I think it makes it a lot more easy to understand what each role can do with each Fabric item. So here are some of the key points to understand. I've actually split it out into 2 tables. One is for workspace administration type duties. And for these, each of the 4 roles can do slightly different things. So that's important to note. But for all the Fabric item related stuff, so all the stuff related to data pipelines, related to data warehouse, all the Fabric item stuff, as I would call it, you'll notice that the permissions for admin, member, and contributor are all the same, which is why I've grouped them. And in general, a viewer in a workspace can only view contents of stuff, right? So for example, they can read a notebook, but they can't execute it. Now, the exception to this rule is the data pipeline, where a data can actually execute and cancel the execution of a data pipeline. And this is one of the only things that a viewer can do over and above viewing stuff. And the other thing to note about the viewer role is that they can only access the SQL endpoint of a lakehouse. They can't access a lakehouse through Spark because they can't execute any code in the Spark environment, or through any other methods, right? So they can't use the TDS endpoint, any sort of APIs. They can't do any of that. They can only use the SQL endpoint. And we'll see why that might be a bit later on. Now, in the last section, we were talking explicitly about workspace level sharing, i.e. giving people or groups access to the workspace, and therefore everything in the workspace. However, we can also share Fabric items individually without having to share the whole workspace. But this is where a common mistake is again often made, because not all Fabric items can be shared individually. And I think this is something that's not widely understood. The data pipeline, the data flow, and the event stream cannot be shared individually at the time of this recording. And the only real option at the moment to give people access to these is to give people access to the whole workspace, which contains these items. So that's something to bear in mind when you're planning out your strategy. Let's take a quick look at the options for individual item sharing. So for the items that you can share, let's look at how they differ. Oh, and to share an item, you just right click on it when you're in like a workspace view, click on share. And then you get this menu item and you'll see the options for the permissions that you'd like to share. And you can select with whom, hopefully a group that you want to share that item with. And for each item, you get a different set of options. And I've copied them here for you to take a look at, right? So each of them are slightly different. So just bear that in mind. Depending on the item that you're sharing, you get a slightly different set of options to choose from. So that's item level sharing, but we can also go to a more granular level if need be. In the data warehouse and the SQL endpoint of the lakehouse, we can get even more fine-tuned access using any of these features. So object level sharing, which is sharing tables and views. So not the whole data warehouse, but an individual table and an individual view with a particular user. Column level security, row level security, dynamic data masking. Now, how to do all of these things is beyond the scope of this video, but just know that it's possible. And if you want to do that, I'll leave a link to the documentation on the school page of this video. So what's the mistake here? Well, not many people are aware of the fact that object level sharing only exists in the data warehouse or SQL endpoint of a lakehouse. But using Spark, these object level permissions are not really respected. It's all or nothing. So if we go back to this diagram that we looked at before, we remember that a viewer in a workspace can only access the SQL endpoint of a lakehouse. And so if you share at an object level with a viewer in a workspace, the object level permissions will be respected. But as soon as you give them contributor or above, they will be able to access the lakehouse tables using Spark. And these object level permissions will mean nothing. So that's something to be careful of. Next up is number 7. And in a Fabric world, it's possible or even likely that you'll be conducting workloads across different workspaces, meaning that you might be planning on reading data in one workspace, doing some cleaning or transformation, and then saving it in another workspace. Now, this is where the final mistake is sometimes made in planning out your workspace design, because people fail to understand the limitations of some of the Fabric items to perform across different workspaces. And I'm talking specifically about the data pipeline. So with the data pipeline copy activity, you can only set a source and destination for data stores in the same workspace as your data pipeline. That means you can't use a data pipeline to orchestrate the movement of data between workspaces. Now, you can use a notebook or a Dataflow to perform cross-workspace reading and writing. So that is possible. And it's a similar story for the stored procedure activity in a data pipeline. Your data pipeline must be in the same workspace as the data warehouse that contains the stored procedure that you're trying to trigger with it. And it's the same with invoke pipeline. Both the parent and the child pipelines must be in the same workspace. So this is something to bear in mind. And for this feature and some of the other features that I believe are missing from Fabric currently, I've added ideas to the ideas portal of Microsoft Fabric. So if you want to follow the link and vote for these ideas to get them introduced to Fabric, that would be awesome too. So now you've got your Fabric environment set up for success. The next thing you need to consider in your transition from Power BI to Fabric is how you'll be getting data into Fabric. Will you be using data ingestion, database mirroring, or Fabric shortcuts? That's what I'll be covering in the next video in this series. In this video, I'm going to be explaining to you how to get data into Fabric. And there's a number of different tools that we can use to get data into Fabric. You might have heard of data flows, data pipelines, Fabric notebooks, shortcuts, database mirroring. There's a lot of different options, and it can be a bit confusing really to understand which ones you should use for which task. So the goal of the video today is to introduce you to these methods to help you make informed architectural decisions. So if you're moving to Fabric, you're going to be making decisions about which methods you should be using. So this video is going to help you if that's you. And we're going to communicate when to use and when not to use certain tools. And I'll be giving you implementation notes that go beyond just the surface level understanding. So on top of just the what are these tools, for each one, I'll be talking you through things you should bear in mind when you're implementing them, because frequently when you watch a YouTube video, it can look like you understand everything, but then when you go to implement it, it's a completely different story. And this video is part of a series that I'm doing on the channel to help you transition from the world of Power BI to the world of Microsoft Fabric. We're on video 3. Which is this video in the series, and there'll be 7 or 8 in this series. So if you're not already subscribed to the channel, then definitely make sure you're subscribed if this is something that you think will be useful to you. Now, I just want to start with a bit of a recap of what we're trying to achieve here. So if you're coming from a Power BI background, this is the kind of workflow that you're probably working to currently. So you've got some source data, then you're going to be using Power Query, probably in Power BI Desktop. You're going to be connecting to different sources of data and transforming them, then building your semantic model, creating your data visualizations on top of that, and then publishing your report. Now, when we think about a fabric-centric architecture, this is going to look a little bit different. So obviously we've still got our source data, and that can be databases, files, APIs, whatever that can be. But instead of putting it straight into kind of a Power BI dashboard, we're going to get it into Fabric and we're going to store the data. So that get data into Fabric, that can actually take a lot of different shapes. There's lots of tools that we can use now to get data into Fabric. That's one of the main differences between kind of the traditional workflow on top, where everything really is done through Power Query. Whereas now in the world of Fabric, we have 4 or 5, lots of different options available to us. And so choosing the right tool for the job becomes very important. And then we build our semantic models from the stored data, and then we visualize them like this. So this is going to be the focus of this video, different options that we have for getting data into Fabric. And the next video in the series will be on storing data and the different options and when to choose which of the different data stores for different use cases in your architectures. So let's just start with a high-level overview of what we're going to be covering in this video. So how can you get data into Fabric? Well, the first method is data ingestion, and you might know this as ETL or ELT, extract, transform, load. Basically, we're going to be connecting to data sources with this method. Then we're going to copy the data from the source and we're going to save it to somewhere in Fabric. And in Fabric, there's quite a few tools that allow us to do data ingestion. We can use the Dataflow, the data pipeline, the Fabric notebook, or the event stream. So we're going to be looking at each of these and understanding what they are, how to implement them, and when we should use certain ones over the other one. Then we'll be looking at shortcuts. Now, shortcuts are a really cool feature in Fabric, and they don't require an ETL process. Instead, with shortcuts, we create a replica of files in external locations. So if you have files already in ADLS, Azure Data Lake Storage, or maybe even in Amazon S3, or in the Dataverse, maybe you've got a Power App, you can create a shortcut to this data, and it creates kind of like a live sync of that data. Now, there's 2 different types of shortcut. We can have an external shortcut, which, as I said, allows us to connect to these external systems, or an internal shortcut that allows us to create links to other tables that we have within our Fabric environment. So we'll also be looking at shortcuts. And finally, I just want to mention database mirroring. And database mirroring at the time that I recorded this, March 2024, is still in private preview. So they're still testing it out privately. So it's not publicly available for people to test yet. But the concept of this is similar to shortcuts, but it allows you to create a live sync of a database, not just some files. And from the marketing, we can see that already they have connectors planned for Snowflake, Cosmos DB, Azure SQL. So if you're using any of these databases in your business, just know that soon you'll be able to use database mirroring to create a live replica in your Fabric environment. Again, with no ETL, it's just always up to date. So let's just start at the top here with data ingestion in general. So this is what we're going to be doing in data ingestion. We're going to connect to source data, use ETL or ELT, and then we're going to store the data and then build our semantic models on top of that. And as you saw previously, we've got 4 real options or tools that we can use to perform this data ingestion. Now, in general, when do we want to use data ingestion over and above the other options, so shortcut or database mirroring? Well, we get access to a lot of out-the-box connectors, especially with data flows. There's over 300 connectors that we can use to connect to a lot of different source systems, and that makes it really easy. Data pipelines as well have a lot of connectors inbuilt, and we'll look at that in a minute. Less than data flows, but still quite a lot. And if you use the Fabric notebooks, you get access to all of the Python client libraries. So perhaps you want to connect to HubSpot client libraries to bring in your marketing data, for example. And there are a lot of Python client libraries. So depending on what tool you use, that can be a really good option as well. And again, it's highly configurable. So especially with Fabric notebooks, you can really do lots of things with your data before it gets written into Fabric. So when do you not want to use this sort of thing? Well, it can be slow depending on the amount of data that you're transferring. With data ingestion, you do need to handle incremental update logic yourself most of the time. Whereas with the other options, so for example, the shortcuts, all of that is managed for you. You just get the live replica in your Fabric environment. You don't need to worry about incremental updates, merging operations, all that kind of stuff. But it's not real time. So with data ingestion, normally you'd run a data flow or a data pipeline, for example, on a specific schedule. Could be every hour, every half hour, every day. So there's always a bit of a lag between the data that you've got in your Fabric environment and the data in the source system, because you're only updating it every hour, for example. So let's just dig into the Dataflow Gen 2 in more detail. So with the Dataflow, you can connect to over 300 different source systems, and these are pre-built, and you can just connect to these systems and bring the data into a familiar Power Query low or no code interface. And then from there, you can perform data transformation, if that's what you want to do, and then write it to any of the Fabric data stores. So when do we want to be using data flows? Well, if you want to make use of any of the 300 external connectors, then that's a pretty good reason. It is a no and low code solution, so you can get by without knowing any coding. You can also use Power Query to kind of extend the functionality if you want to. But for most people, it's suitable for practically anyone can write a data flow. Another point to remember about the data flow is that it can do extract, transform, and load. You can do all three of those things in one tool, which some of the other ones can't do. Now, the data flow can access on-premise data. It's the only tool in this list that allows you to set up an on-premise data gateway, and you can access it via a data flow. So if you have on-premise data, you're going to be wanting to using data flows currently. Now, I do think that in time, Microsoft will build the functionality to allow you to access on-premise data via data pipelines as well. But currently, Dataflow is the only way of doing that. So the next point is that you can actually access more than one data set at a time. What I mean by that is you can build multiple Power Query queries in the same data flow and then combine them if that's what you want. Although you might want to space these out and just do one data set per data flow, write them into Fabric, and then combine them later on in your pipeline. In 2 videos time, we're going to be talking about data validation. And so by spacing out your transformations, it allows you to validate the data. So that is an option in data flows, but you might want to think carefully if you're going to do that. So when do you not use it? Well, in my experiences and quite a few people that I've spoken to in my community as well, there's struggles with large data sets. So if you've got gigabytes of data that you're transferring regularly, data flows can be quite expensive in terms of capacity usage and time taken to perform these things. And as I've just mentioned previously, it's difficult to implement data validation with this method. Now, it's good if you want to do extract and load functionality and then validate afterwards. But if data validation is important to you, which it should be, then it's difficult to actually implement this in the tool itself. So here's some implementation notes for the data flow. And these are just things that I've picked up over the last 9-ish months working with data flows and from speaking to lots of people and reading about lots of different things to bear in mind when you're implementing data flows. So you can include data flows within a data pipeline, and this can help with orchestration and logging as well, and also error handling. So out of the box, data flows don't really have error handling. So if there's a problem in one of your transformation steps, it's just going to fail. And you can't do anything after it fails. But if you embed your data flow in a data pipeline, which we'll talk about in a minute, you can handle those errors a bit more gracefully. Building on that, the data flow in the data pipeline can enable the ELT pattern. So extract, load, transform, whereby we get data from somewhere, and we write it somewhere, and then we read it from that location, transform it, and then write it to a transformed location. And we're splitting those out into 2 separate parts, and we can orchestrate them in a data pipeline. So parameters are not yet implemented. So if you've used data flows or even the Power Query engine in Power BI, you'll be familiar with the concept of parameters. And this is not yet implemented in Dataflow Gen 2, but if you have this data somewhere in Fabric, then you can kind of mimic the effect of parameters. Next, there's no ability for looping out the box. Now, you can code your own if you're familiar with Power Query, but it's probably better to manage this with a data pipeline. So if you need to implement control flow logic, then it's probably best to do that in a pipeline or in a notebook if you know Python. Now, an example of when you might need this is maybe if you're retrieving data from a paginated API, for example, and you need to loop through the different pages of the API to get all of the data. Now, one thing to bear in mind is that with large data sets, then data flows can struggle. Now, I know they're making a lot of improvements, but I think there are still some issues around very large data sets. So if you're using very large data sets, then I'd probably suggest you use data pipelines or notebooks. Now, there is a feature called staging that helps, or is supposed to help with this, but it can actually have the opposite effect in some instances. And basically what staging does is it's going to create a kind of temporary lakehouse that's going to store your data and it's going to do the transformation on the lakehouse data instead of doing everything in the data flow itself. And the theory is that this will speed up your transformations, but I'm not sure how successful this is working at the moment. And one thing to bear in mind if you're watching my last video is that it can perform reading and writing across different workspaces. So you can read data from a table in Fabric in one workspace, do some transformations with it, and then you can write it to a table in a different workspace. That's something that you can't do with data pipelines. So next up, we're going to be talking about the data pipeline, and this is primarily an orchestration tool. So you can create different activities that you're going to run through in a kind of workflow, but we can also use the data pipeline to get data into Fabric using the copy data activity. So when should we use the data pipeline? Well, as I mentioned previously, it's much more efficient when copying very large data sets. And it's particularly efficient at importing data from cloud, so from Azure Data Lake Services, Azure SQL, all of those kind of services it works really well with. And as I mentioned previously, it's good for when you need to implement control flow logic. So if this, then do this, otherwise do this, that kind of thing. That's when data pipelines are really useful. And data pipelines can trigger a wide variety of actions in Fabric and also outside of Fabric as well. So we can trigger data flows, we can trigger notebooks to run, we can trigger stored procedures, both Fabric data warehouse stored procedures, and even stored procedures in external databases like an Azure SQL database. You can use it for that as well. We can use it to trigger KQL scripts, generic webhooks, Azure functions, Azure machine learning, and Azure Databricks as well. So all of these kind of connectors are built into a data pipeline and it can trigger different things depending on your workflow. So when do we not want to use this? Well, data pipelines don't really have any transform functionality natively. So we can't really do data cleaning in a data pipeline. Normally, if you want to do that, you would embed a notebook or a data flow into your data pipeline. And as we mentioned previously, we can't use it currently for accessing on-premise data. So we can't set up a data gateway and connect to it via a data pipeline. Now, there's no ability to upload local files. So one thing I didn't mention previously is that with the data flow, you can actually upload kind of one-off local files and then transform them and then get them into Fabric. That's not an option with the data pipeline. And from a previous video, you'll know that it doesn't work really very well at all with cross workspace. So you can't read data from one workspace when your pipeline is in a different workspace, and you can't write it to a different workspace. And you can't trigger stored procedures, all these different things when they're in separate workspaces. So that's something to bear in mind as well. So let's dig a bit deeper on some of the implementation notes. So for users of Azure Data Factory, the data pipeline is quite similar, very similar in fact, but there are a few differences or limitations with Fabric data pipelines. So the big one is that currently only schedule triggers are available in data pipelines in Fabric. So you can only really trigger it via a schedule. And mapping data flows, if you've been used to using them in Azure Data Factory, these have been kind of replaced by the Dataflow Gen 2. Next, we cannot connect to on-premise data gateways. That's what we've mentioned previously before. Next up, you can build nested structures, nested workflows to help with control flow in data pipelines. What we mean by this is that you can invoke pipelines from another pipeline. So this becomes quite powerful in terms of scalability and maintainability of sometimes quite complex data pipelines. And this is typically used in conjunction with a metadata-driven approach. So what this means is you're going to create a lakehouse or a data warehouse with metadata about all of the different pipelines. So if you need to write 100 different data pipelines, then either you can create 100 data pipelines, or you can create a lakehouse table with 100 rows, and each row gives the metadata for a particular pipeline. And then you just query that lakehouse table, loop through all of the rows, and kind of build a data pipeline on the fly. So that's a fairly established approach for dealing with data pipelines in general. And it really helps you to scale up into the tens or hundreds of data pipelines very simply. And it also helps with maintainability, of course. And finally, you just need to be aware of the cross-workspace limitations when using data pipelines. So your data pipeline must be in the same workspace as where you want to write the data to or read data from as well. Next up is Fabric notebooks. Now, Fabric notebooks are obviously quite general purpose. You can do lots of different things with them. But in this context, we're going to be talking about using them to get data into Fabric. We can do that normally by connecting to APIs. We can use Python libraries such as requests to query APIs, REST APIs, to get data. Or we can use client Python libraries. So if your data is in HubSpot, for example, and you want to extract that, well, HubSpot actually has a Python library for accessing your data. So it can make it quite easy to connect to data if the place where your data resides has a client Python library, which a lot of them do for the major SaaS providers. And also kind of the big platform as a service, Azure tools as well, also allow you to extract data using Python. So when should we use notebooks? Well, as I've just mentioned, it's really useful for extraction from APIs because sometimes authenticating with APIs can be a bit fiddly. And although you can do that with a Dataflow and a data pipeline, it's a lot simpler to do it if you know Python using Fabric notebooks. You can really get very customized API logic for handling tokens and all this kind of thing. So if you've got complex APIs, I'd recommend using Fabric notebooks. And again, if you want to be using those client libraries, the only opportunity to use those is with Fabric notebooks. Obviously, it's really good for code reuse. So you can write a connection once and then you can use it all over your company. You know, if you need to reuse your code, that's quite simple to do in a notebook. And one of the major benefits is that you can embed data validation and data quality testing on the incoming data. And notebooks are one of the only opportunities that allow you to do that very easily. And in this series, I'll be having a whole video where I'll be talking about how you can be doing this. So notebooks are built on top of the Spark engine. So if you have really large data sets, then you can use the Spark engine to speed up getting this data into Fabric. So that's when we should use Fabric notebooks, but when should we maybe not use Fabric notebooks? Well, the main one really is when you don't have a Python capability in your organization or you don't want to grow a Python capability. So if you only really have people that know SQL or Power Query or no-code, low-code tools in general, then it's obviously not recommended to use Fabric notebooks. So that was data ingestion, but what if we don't want to do this repetitive ETL process? For some data sources, Fabric provides functionality to replicate data from your source into Fabric. Let's look at some of these approaches in more detail. So let's start by talking about, in general terms, what we mean by file and database replication. So if we don't want to do this data ingestion thing that we've just been talking about, then we can create live syncs to files, and soon we'll be able to create live syncs to databases as well for external files and databases, things that live outside of Fabric. Now, the way to do that for files is using OneLake shortcuts. And for databases, it's going to be using database mirroring. This is a feature that's coming soon. Now, the key thing to know here is that there's no ETL. So there's no going to the source, copying new data into Fabric, writing these merge statements yourself. No, it's not going to be any of that. So how does the file and database replication work? Well, for both shortcuts and database mirroring, they both work fairly similarly, conceptually at least. The first step is to create a connection to your source. Then Fabric is going to create a delta table kind of like a cache of the full data set the first time you connect to this source, because you need to get that data into Fabric for the first time. And then Fabric is going to monitor that source for updates, and it's going to automatically sync the source with that Delta table cache that they've got in Fabric whenever you make updates to the source. Now, obviously, the pros of doing this is that you get near real-time updates to your data available to you in Fabric. You don't have to worry about any of the merge or update logic that you do with ETL. And the updates are incremental, which meaning that potentially it could drastically reduce the amount of capacity that you're using for these kind of things. Now, the cons of file and database replication in general is that currently it's only a limited selection of data types and data sources that this works with. So let's dive into shortcuts first and look at what some of these data sources are. So this is the OneLake shortcut, and a shortcut enables you to create a live link to data stored either in another part of Fabric, which is an internal shortcut, or in external storage locations such as ADLS, Azure Data Lake Storage, or Amazon S3. Now, one thing to bear in mind quickly with internal shortcuts is that there are some limitations about what we can shortcut to where. So if we start by looking down the left-hand column here, if we look at from a lakehouse table to another lakehouse table, then yes, we can do that. So what I'm trying to say here is we can create a shortcut from a lakehouse table to a lakehouse table. Similarly, we can create a shortcut from a data warehouse table to a lakehouse table, and a KQL database to a lakehouse table. And it's the same where the target location is KQL database. So you can shortcut anything into a KQL database. But with the data warehouse, you can't shortcut a lakehouse table into a data warehouse, and you can't shortcut a KQL database table into the data warehouse either. Now, in the middle here, I put a green tick, although it's not really a shortcut, but you can do cross-warehouse queries, which act like a shortcut. So you can connect 2 or 3 different warehouses together, and it acts a bit like a shortcut. So that's why I put a green tick in that middle box there. So that's something to bear in mind. So implementation notes for OneLake shortcuts. So a shortcut can be set up for individual files, but more commonly for a folder. So a whole folder in Azure Data Lake, for example. And you can create a shortcut to a base folder or a root folder, and it will monitor and sync all of the files in separate subfolders. For internal shortcuts, the user will need access to both the source and the target location to be able to access the shortcut data in Fabric. Now, you need to be careful of cross-region egress fees, and this is what I mean by that. So if your Fabric capacity is in UK South region, for example, but your ADLS storage account is in West US, for example, you will be charged a cross-region egress fee every time that data is transferred. And that currently is at 1 cent per gigabyte. So it's not too much, but it can add up. Recently, Microsoft have also announced that you can create shortcuts via the Fabric REST API. So if you're into automation, then that's definitely something to check out. That's a newly released feature for the API. Now, next, we're going to talk about database mirroring. Now, this is a feature that is currently in private preview as of March 2024, but it is expected to be released in Q1 of 2024. So basically, I would expect to see that by the end of March. And a database mirror allows real-time data replication of external databases as delta tables in OneLake. And again, this prevents the need to ETL the data from the database. So this is what this looks like here. So you can have a Snowflake database, or maybe you have data in Cosmos D, or perhaps you have a .NET application in Azure SQL. The backend is an Azure SQL database that you want to bring into Fabric. Now, you could do a traditional ETL using data pipelines or data flows, but it's not going to be real time. You're going to be querying it every hour. And for some applications, you might want a more real-time replica of this data in Fabric. So say this is our goal. We want tables in Fabric. What we're going to do is the first time that you set up database mirroring, it's going to convert the tables that you have in the source database into Delta Parquet format, and it's going to write them into OneLake. And then what it's going to do is set up kind of like a subscription to that database that's going to check for updates. And it uses a protocol called change data capture that these databases have within them that allows them to pass updates to Fabric. And what that means is that any updates that you make in the source location, in your Snowflake database, for example, these are automatically written into your Fabric mirror of that data set. So again, it prevents data duplication, and it also eliminates the need for ETL. And another thing to bear in mind is that you can use the Fabric Delta format for time travel and history tracking of these tables. So if you've used, for example, Azure SQL, you can build history tables within Azure SQL. But another option is to let Fabric and the Delta technology handle that history rather than having to rely on the SQL and building history tables that, if you've ever used them, they're not particularly great. Delta has much better functionality for tracking history. So if you want to keep a record of how your tables are changing over time, then this is a particularly good method for that. So that's a high-level overview of the tools available to us. How do we decide which to use? Well, to kind of summarize everything that we've talked about here, I just want to go through a few key considerations that we should bear in mind when you're choosing a method for getting data into Fabric. So the first one is the need for real-time data. So if you have a requirement where you need near real-time data, then it's going to be pushing you towards a shortcut and database mirroring when it's eventually released. The other thing to consider is what the skill sets are in your team. Is it predominantly low code or no code in your team? Do you have professional Python developers? If it's the latter, then notebooks offer the most flexibility in terms of getting data into Fabric. So if you do have a proper data engineering capability within your organization, you're going to be using data pipelines and Fabric notebooks probably for most things, I would argue. So another thing to bear in mind when you're choosing between these methods is the cross workspace limitations, specifically of data pipelines, and we talked about that a lot in this video, but also the last video more as well. You also need to think about scalability, and alongside that is the size of your data. So as we've discussed, different methods here are better or worse at handling large data sets. If you're transferring gigabytes of data, or lots more data every day, then that's going to have an impact on the method you choose, as we've discussed. Now, on that note, I do think that Microsoft are working pretty hard to make sure that all of these data ingestion methods have a similar kind of speed. So I would definitely watch that space to see how those improvements are made in time. So another thing I wanted to mention alongside that is the cost and capacity usage. So if you're particularly sensitive over the amount of capacity usage that your data ingestion methods are going to use, then I recommend doing some mini tests of getting a sample data set, ingesting it in via different methods, including shortcuts if your data is in ADLS or Amazon S3, and when it comes out, database mirroring as well, and comparing which of these methods uses the most or least capacity usage. And this is something that I'll be doing hopefully in a video coming soon on this channel. As well as that, another important consideration is the need to access private endpoints or on-premise data. And again, there's been lots of new features released in Fabric to help you do this. Now, each of the different tools for data ingestion in Fabric handles this slightly differently, and there's a lot to go through with this. So I'm going to be dedicating a whole separate video on connecting to private endpoints, trusted workspaces, on-premise data, all of that kind of stuff that trips people up quite often. So if you made it this far, thank you very much for watching, and I would love it if you leave this hourglass emoji in the comments just to let me know that you've watched all the way through. And if you have any questions, I recommend you join our Learn Microsoft Fabric community, and I answer any questions that you might have in there. You can find the link here. In the next video, we're going to be looking at different data stores in Fabric and understanding when you should use which, the pros, the cons, all that good stuff. Thanks very much for watching. Hey everyone, and welcome back to the channel. Today we are continuing the Power BI to Microsoft Fabric Transition Guide series with a very important one. Now, one of the biggest mistakes that people can make when they're moving to Microsoft Fabric is to select the wrong data store. So in Fabric, there's three main data stores. We've got the lakehouse, the data warehouse, and the KQL database. And each of these have slightly different characteristics, use cases, features, and also limitations. And if you don't fully understand these things, then you might not make the right decision for your requirements in your business. So in this video, we're going to be going through each one in detail, understanding what they are, what they should be used for, again, understanding the features and the limitations and comparing them side by side. And then in the second half of the video, we're going to be learning about how you can combine these different data stores into some sample architectures. So we were going through some use cases. Typically, these aren't just used on their own, but in Fabric, you might be using one or two lake houses plus a data warehouse, maybe a KQL database as well if you're using real-time data. So that's what we've got in store for you today. Enjoy the video. So to start us off today, I'm actually going to start in the OneLake File Explorer. So this is a plugin that you can download and it acts a bit like OneDrive for your local machine. And the reason why I'm going to start here is to understand that under the hood, the lakehouse, the KQL database, and the data warehouse, they all store their files in the same format. And this is particularly visible when we look in the OneLake File Explorer. So here I've connected it to my Fabric environment and we can see different artifacts, different Fabric items. And when we click on it, it's just folders. So we've got a tables folder, and then these are tables in my lakehouse. This is a lakehouse. And if we click into this, you can just see the Parquet files and the Delta log. So these will be JSON files that just show the Delta log for that particular table in the lakehouse. And if we go to another one, so this is my workspace. If we go to, for example, this data warehouse, you'll see that it's exactly the same structure. Tables, we do have a schema in the data warehouse, but if we click through, then we can see that, again, we've just got some Parquet files and the Delta log. So under the hood, everything is exactly the same. So that's the first point to note about all these different data stores. Under the hood, it's the same data. So what is different then? Well, when we flick through to the UI, here we're in a lakehouse. And I'm just going to give you a quick tour of each of the three data stores just so that you can understand what they look like and what you can do and some of the unique features in each one. So here we are in the lakehouse. And what's particularly unique about the lakehouse? Well, we have access to tables and files. So the lakehouse, we can store structured data. So this is these tables. For example, here we can see a preview of data in these tables. But what's unique about the lakehouse is we also have this files area. So the lakehouse, kind of the definition of a lakehouse is that it's part data lake, i.e. files, unstructured data, and semi-structured data. So data in CSVs and JSON, Parquet, whatever you want. And we can also have completely unstructured data. So image data, audio data, and if you're a data scientist, then that's really useful, right? Because you might be doing some image analysis, computer vision problem, all that kind of stuff. You're going to be saving your data into a lakehouse files area. And one of the main kind of workflows that we use in the lakehouse is to get data from an external system. It might be a REST API, might be files in ADLS, for example. We're going to bring them into our files area. We're going to pass them, transform them, clean them maybe, and then we're going to put them into more structured tables so that we can use them later downstream in our pipeline and visualize them in Power BI, for example. So for that reason, the lakehouse is very often used as the bronze layer in the medallion architecture because it can handle both files and tables. So in terms of using the data in a lakehouse or interacting with this data in the lakehouse, the tool that we use is a notebook. So hand in hand with the data in the lakehouse, we use notebooks to analyze or visualize or transform or validate or test all of this stuff. And you can create a new notebook just by clicking on Open Notebook. If you've got an existing one, you can link it to this lakehouse, or you can create a new one. So I've got one here. I'm just going to click on here. So the thing to know about the notebooks is we can write code in a variety of languages. And the notebook is built on top of the Spark engine. So if you watched my 38-minute video introducing you to Microsoft Fabric, you'll know that the engine behind the lakehouse and the data engineering experience in general and the data science experience, that is going to be the Spark engine. And because of that, we get access to 4 main languages that we can write in a notebook. We can use PySpark, Spark Scala, Spark SQL, Spark R. And that's if you want to use the Spark engine. So if you have really large data sets, then you're going to be wanting using the Spark engine, because it's going to be able to chop through all this data in a parallelized way. And I've got a whole series about using Spark and notebooks in general. It's about a 4-hour long video. I'll leave a link to that in the description below if you want to learn more about that. But it's not just Spark as well that we can use in notebooks. If you've got slightly smaller data, you can just write conventional Python and use libraries like pandas and matplotlib and all this good stuff. That's also available to you, but you won't benefit from the parallelization that you get with Spark. So we can also create shortcuts in the lakehouse. So we can create shortcuts to anywhere in Fabric. So this table here is a data warehouse table, and you can see there's a small link there in this Delta table icon to indicate that it's a shortcut. So this data doesn't actually live in this lakehouse, but it's accessible to us in our notebook code, for example. Now, as well as the lakehouse view, which is what we've been looking at currently, the lakehouse also has the SQL endpoint. So we can write T-SQL scripts to view data in our lakehouse. Now, the important thing to note here is that it's read only. So you can't do anything like alter tables, adding columns, update, inserts, deletes. You can't do any of that. Only really select statements. And you can also create views on that data as well. So that's the only real write capability, because the view is not actually altering the underlying data set, right? So here we get a view that looks a lot like the data warehouse, but it's actually the data in a lakehouse. And we can write T-SQL scripts as well. And we can also create measures from this data, DAX measures as well, build semantic models and all that good stuff from this view. So next up, we're going to look at the data warehouse. So here we are in the data warehouse. And if you've used any sort of SQL database before, it's a very similar structure. So we have schemas, we have tables, views, functions, stored procedures, right? And the language that we're going to be using in the data warehouse is T-SQL. So we can write T-SQL queries and then we can save them for our colleagues to look at as well in this My Queries and Shared Queries option. So the data warehouse is going to be very familiar for database developers, SQL developers, maybe even Power BI developers that have used SQL before. So a typical workflow or workload that you might be doing in the data warehouse is more towards the end of the data processing pipeline, right? The gold layer of a medallion architecture, for example. You might be creating dimensions, creating aggregates, analytical models in here, because you might already have SQL code that describes business logic in your organization, right? And you're going to be using SQL to write those things. And again, you can create semantic models from your data in your data warehouse. Okay, so here we are in the KQL database, and I've got some data here just from the weather sample, which is the sample data set that you get in Fabric. So the KQL database really is built for streaming and real-time data sets. So we have a few different data sources that we can connect to get data into a KQL database. Now, some of these are like one-time operations. So if you've got a big batch of IoT sensor data for the last 2 years, you can upload it here and just store it in your database. But the main use case really for KQL is these continuous data sets. So we can use event streams or connect to existing Azure Event Hubs to stream data into the platform. So once we've got some streams set up, we organize things in tables. We can also use shortcuts, and we can also use materialized views. So if you've used Azure Synapse or dbt or any sort of database that incorporates materialized views, basically means we can create a view of the data, but then we write it out into a materialized views, which acts more like a table, and it improves read performance when we're, for example, querying it in Power BI. We can also create functions and data streams. Now, in this one, I haven't actually got any set up, but that's just to give you a bit of an idea about what the KQL database looks like. Now, in terms of languages that we're going to be using in the KQL database, well, the main one is KQL, and we can also implement SQL kind of as well. So here we've got a bit of a cheat sheet that's included in the documentation, and if you use this keyword explain in a KQL query language statement, it's going to output the KQL. So if we try that, then, so say for example here, I'm going to create a new KQL query set. Now this is going to take us through to the query set editor. And so if we only know SQL, then we can just copy this and it's going to return a KQL query. And then if we want, we can copy that, paste it into our editor, and then just run that. And then we get the result. So if you're familiar with SQL, then that's a good way of kind of learning KQL as well. So that's a bit of a tour of the three main data stores that we have in Fabric. Now let's do a bit of a side-by-side comparison, just to summarize everything that we've gone through so far. And I'm going to be talking about a few other considerations when we're comparing between these three different data stores. So let's jump over to the iPad and I'll walk you through those now. Okay, so here we are down in the iPad, and what I've got is a bit of a side-by-side comparison of the three tools. So the three data stores that we have in Fabric are the Lakehouse, Data Warehouse, and the KQL database, as we've just seen. And then to give it a bit of structure, I'm going to be talking through these things down the left-hand side. So what are the different data types we can use, the languages, Copilot integration, the different ecosystems that that particular data store might open up, which I think is very important, the different security considerations that we need to bear in mind and configurations that we can make in each of these, the typical workloads, the unique features of each of them, and the personas. And then afterwards, what we're going to do is look at some end-to-end architectures that combine these different data stores in some unique ways, depending on the requirements in your organization. So let's get started in this and talk about the data types. So we're going to be basically revising what we just spoke about earlier, just to reinforce what we were talking about. So let's start with the data types for the Lakehouse. And as I mentioned, we can do structured data, and by that we mean tables. We can also do semi-structured, so things like CSV in the files location, and JSON, for example, from a REST API. And we can do unstructured data, and by that we mean images, audio, anything really. And this is particularly useful for data scientists if you're doing AI projects based on computer vision or anything like that that requires the analysis of unstructured data. We need to get that data into Fabric, and the place we're going to get it in is in the files location in a Lakehouse. So the data warehouse, we only have the structured data, right? We only have tables really. Now KQL is kind of so we have the structured tables. We can also do semi-structured because we can import files that we can analyze in a kind of one-off batch scenario as well. Okay, so next up we're going to be looking at the languages. So for the Lakehouse, obviously we have access to the Spark engine. So we can write any languages that we can write with Spark. So for Spark, that's going to be Spark SQL, which is similar to T-SQL, but there are some differences. You've obviously got PySpark, did a long series on that, Spark R, and Scala. Now on top of the Spark languages, we can actually also write just raw Python, right? So Pandas, Matplotlib, Seaborn, all those traditional Python languages as well. And on top of that, we can also actually write T-SQL as well in the Lakehouse via the SQL endpoint. But that's going to be read only, right? So we can do select statements, but we can't do inserts, updates, deletes, any of that stuff. In the data warehouse, really, we only have T-SQL, right? So we can write queries, stored procedures, all that kind of stuff there. Now, one thing to bear in mind here is that if you have a table in your data warehouse, then there is an option to shortcut that into the Lakehouse, right? So this is my shortcut logo, very bad. But then we can create that here, and then we get access to all of these things as well, right? So just because you store your data in the data warehouse doesn't mean that the only thing you can do is to use T-SQL. You can still shortcut it into the Lakehouse if you need to use PySpark or anything like that, right? But natively, you only have access to T-SQL. And the T-SQL here, importantly, is read and write. So you can do inserts, updates, and deletes with data. So that's one of the main important things about the data warehouse, right? So the KQL database, obviously it is KQL and SQL as well. So in terms of Copilot integration here, so if you're using an F64 capacity or P1 capacity, then you get access to Copilot in the lakehouse experience, or technically in a notebook, right? But the notebook's connected to a lakehouse. So yes, that is available in the lakehouse. Currently, there's no integration with the data warehouse, so you can't use Copilot to write your T-SQL scripts, for example, and it is integrated into KQL. So that's something to bear in mind if you want to take advantage of low and no code stuff, then Copilot is accessible to the lakehouse and KQL. Now, I'm sure they will build this soon, but currently it's not available. And whilst we're on the topic of no code and low code, there's a few different options there as well for each of these. So with the lakehouse, I'm just going to add in a new topic here, like low code, no code. Bit messy, but is what it is. So in the lakehouse, obviously we have Copilot. We also have Data Wrangler, which is a feature that kind of helps you build Python queries, Pandas as well, if you're not too familiar with those languages. In the data warehouse, we have visual queries. So this is where you can create a query just using a UI interface. So if you're not familiar with T-SQL, you can still build queries with that as well. And in the KQL database, I don't think there is anything that's low code and no code. I might be wrong with that, but I think currently there's no options for no or low code. Okay, next I want to talk about ecosystems, because this for me is a very important point to consider when you're choosing a data store. So let's talk about the lakehouse first. And because the lakehouse is built on top of the Spark engine and we can use Python, this opens up the Spark ecosystem and the Python ecosystem if your data is stored in a lakehouse. And with these, you get a lot of stuff, right? So you get things like machine learning. There's huge existing ecosystems in both of these tools. So for data scientists, really you want your data to be in a lakehouse, and you can easily access machine learning libraries and build machine learning models on top of that data. But other examples might be things like data validation frameworks, particularly Python. There's a lot. And in the next video, I'm going to be talking a lot about data validation and how to implement that across all of these different data stores. Now, in terms of ecosystems in the T-SQL world with data warehouses, the good thing is that it opens up SQL projects. So we can manage our T-SQL code and our database configurations using SQL projects. And we can also use dbt, right? So dbt is a third-party tool that is very commonly used for analytics engineering. So what that means is we can use it as the transform tool, and it's all in SQL, right? So you can connect it to your Fabric data warehouse, and you can use it to build aggregations, you can use it to build analytical models, all that stuff. And the good thing is that your code in dbt is source controlled, and there's a lot of functionality for validation. So this is a really powerful ecosystem to tap into if you're going to be using the data warehouse. Now, the KQL database, I'm sure there are ecosystems, but I'm not actually aware of them. So I need to check that out. But I can't really comment too much on the ecosystems that the KQL database opens up. But it is a very mature framework, so I'd be very surprised if there's not existing ecosystems and tools that we can plug into that. Okay, so next up, I want to talk about the security configuration options with each of these. So let's start off with the lakehouse. What I mean by security configuration is how granular can we get with sharing objects or rows or columns and that kind of thing in each of these? Well, in the lakehouse, if we're using the Spark engine, then there's actually none. So we can't really do any of that if we're using the Spark and we're accessing our lakehouse via notebooks. So that's something to bear in mind. I talked about this a lot in one of the previous videos about access control in this series. Now, if we're using the SQL endpoint, then you do get access to row level security. Now, one thing that I mentioned in my previous video is that this row level security is only enforced if you give viewer roles only, right? Because anything higher than a viewer role, so if you give them contributor, then technically they are going to be able to write a notebook, and then your row level security is not really enforced. So if you want to lock down at the row level for lakehouse data, then you want to be giving people maximum of viewer permissions only. Now in the data warehouse, there's a lot more options for granularity in terms of what we can share with people. So we can share at the object level, which is a specific table, a specific view, for example. We can also do row level security. We can also do column level security. So if you want to hide particular columns from particular users or groups, then that is possible in the data warehouse. We can also do dynamic data masking, which means masking sensitive data in particular columns for particular people or groups. So if you've got sensitive information like an email or credit card, for example, that data can be masked in that column if you use dynamic data masking. So there's a lot more granular permissions that we can apply in the SQL data warehouse, if that's what you want. And in the KQL, we have access to row level security, and that's it. Okay, so in terms of the typical workloads that we have here, so if we look back at what we've written here, we can start to understand what the typical workloads might be, right? So if we start on the lakehouse, well, the fact that we can have unstructured and structured data in the same place means that a typical workload really is getting data from outside of Fabric, parsing these files, getting them into a structured format. So this file to structured transformation is a typical workload that we can do in a lakehouse. And especially if this file is complex. So if you have to do a lot of parsing, if you've got really nested JSON structure coming in, really you want to be doing that with code, right? Because it's a lot simpler than doing it with SQL or anything like that. So that's a particular use case that you would definitely use the lakehouse and notebook for. On top of that, any sort of machine learning, data science stuff, you're really going to be wanting your data in a lakehouse. Now the data warehouse here, some typical workloads, we're going to be doing analytical modeling, normally in preparation for Power BI. So like dimension creation, facts, star schemas, creating all that stuff, aggregations, all of that. And for the KQL, obviously the main workload is for incoming streaming data. It's got a lot of inbuilt functionality for time series analysis. Now obviously you can use Python for time series analysis, but what I mean by time series in this instance is time series on real-time data as it comes into the system, right? Not just in a batch processing style time series analysis. So in terms of unique features for these three data stores, another thing that we haven't quite mentioned yet is Git integration. So in terms of the Git integration for each of these, the lakehouse is an artifact that you can back up with Git. Now currently the data warehouse is not supported, but that's, I'm sure, will be supported soon. And also if you're using SQL projects, then there's an opportunity to use that as your Git integration method. And the KQL database as well, I don't think is supported via Git. Now some other unique features that I want to mention here for the data warehouse is table cloning. So that is particularly unique to data warehouse. And what that is you can create clones of tables in your data warehouse for development and testing, right? So if you've got a dimension table in your data warehouse, you can create a clone of that dimension table, alter it, change the structure of it, and then kind of test it out before then reintegrating it into your main code base, your main dimension table, right? So that's a feature that they released fairly recently. And if that's something you want to be doing, then just know that that exists there. Okay, so finally, personas, right? So hopefully it's fairly clear who's going to be using which of these. In the lakehouse, typically we're going to be having our data engineers and our data scientists, because they're going to be the ones that are comfortable writing Spark code or Python code. They're going to be wanting using machine learning. They're going to want to be doing data validation, all that kind of stuff that is easiest in the lakehouse. Now for the data warehouse, you're going to be having DBAs/developers, database developers, maybe Power BI if they know some SQL to create dimensions and facts and things like that. If they can create them for themselves, that's great. And the KQL is going to be data engineers, analysts who are comfortable with real-time and KQL. And yeah, that's basically that. Okay, so we've gone through quite a lot of different considerations there things you need to think about when you're choosing a data store. Next, I just want to finish by looking at some sample architectures, right? So taking into account all of this, we can begin to understand that some data stores are better suited to some tasks and others are better suited to others. So if we talk in general terms about the data processing pipeline, we have data coming into Fabric here, and at the other end, we're going to have a dashboard with your user on this end, right? And if you think about a sliding scale from unstructured or semi-structured, so these could be like files, API data, databases, and it's typical that these are in not good shape when they enter Fabric. And the goal is to gradually create more structure in our data pipeline, right? So as we move from left to right in this pipeline, actually this should be here. The goal is to clean, transform, add structure to these semi-structured and unstructured data sets, right? And normally that involves converting from this area might be files, and this part of the pipeline is going to be tables. So then when we think about how we architect a solution here, well, towards this end, really, we need to start at least with a data store that can handle practically anything, right? Because these are all going to be different formats. You don't know what format they're going to be in. We definitely need a place to store files and tables. So typically, we're going to start in an end-to-end pipeline with a lakehouse because we can have files and we can have tables, right? So all of our files can get stored in here, data from APIs, even database data we might bring in and write it as Parquet, for example. Then in our lakehouse, we can create notebooks that validate and clean and transform all of this raw data. And then we're going to have some tables in our lakehouse that would be like raw tables. Like we haven't done anything with them. We've just got the data out of files and put it into a table, given it a bit of structure, but we haven't done much cleaning or validation. Then typically from here, we want a platform where we can do data engineering and data science a lot of the time. Or if you need that in your organization, then typically what most companies will do is create another lakehouse that's going to read in these raw tables and do things like cleaning, getting them into a more refined state, right? Now it could be conforming, and by that we mean merging different data sets into a single data set. So if you've got a customers table, you might want to bring in data from 3 different source systems and conform that into one table that is your kind of master customers table, for example. Also, this is where your data scientists might be working, right? So you might have some tables that take these tables here and then add another layer of insight, right? So it could be predictions or it could be some sort of data science analysis. So you're creating new data from your existing data. And then in this part of the analytics workflow, where you're getting close to Power BI, right? And Power BI developers like structure. Now, either this layer, it's typically a data warehouse because you have to think about the skill sets available in your organization and who is going to be wanting to do this kind of stuff. So here we mean like creating star schemas, creating aggregated data sets that are going to be fed into Power BI. And typically the people that are building these things are a lot more comfortable with SQL. So that's why in this layer of our pipeline, a data warehouse makes a lot of sense, right? Now you could have just lakehouse, and lakehouse here, but it would require people in your team to know Python. So they'd have to build all of these things, like your dimensions and your facts, in Python, which is possible, but it's not what most companies do. Now, the way that you would integrate a KQL database into here is if you had streaming data, then you'd probably want a KQL database here. So you could create an event stream that's getting stored, analyzed, and processed in your KQL database. Now, what you can then do is then route that into your silver layer of this medallion architecture. So once you've kind of got the insight, you've done some analytics in real time, then you probably want to save that data into more long-term storage on this lakehouse. So that's how you'd integrate a KQL database into this kind of architecture. But all these things are highly dependent on the skills that you have in your organization. So hopefully now, it's quite a long video, I've been talking for a long time, but I think this is really important material. People are making these decisions about which data stores they're going to be using in their organizations. So hopefully now you have a better understanding of the key features for each of these, some of the limitations, some of the things you need to bear in mind with each of them, so that you can make good informed decisions about when to use each one. In the next video, we'll be focusing on data validation. And this is one of my favorite topics. How do we introduce data validation into an architecture like this to build a system of data quality assurance at each stage in your data processing pipeline? So make sure you join us for that. Hello and welcome back to the channel. And in today's video, we're going to be continuing the Power BI to Microsoft Fabric Transition Guide series. So after a bit of an introduction to the series, we first looked at how to set up your environment in Microsoft Fabric. So how to set up capacities, workspaces, access control security, all of that stuff. We then looked at how to get data into Fabric using either data pipeline, Dataflow, shortcuts, notebooks, all of that kind of stuff. In my last video, we looked at where to store the data. So are you going to choose a data warehouse, a lakehouse, or a KQL database? And so in this video, it makes sense that we continue that path and look at the next step really, which is how do we connect data in our data stores, so in a lakehouse for example, to Power BI. So how do we build semantic models on top of lakehouse data? And we're going to explore in a bit more detail something called direct lake mode, which if you're a Power BI developer, you've probably already explored a little bit already, because I know for a lot of Power BI people, this is the number one feature. And we'll explore a little bit about why that is and the benefits of direct lake, as well as some of the configuration options that you need to bear in mind just to make sure that it's working correctly for your requirements. So the starting point for this video is that we've got some tables in a lakehouse. We've got 4 tables here, and these tables represent Yelp review data. So the data set comes from Kaggle, and Yelp is a website where you can leave reviews on businesses and restaurants and things like that. And this is a collection of all those different reviews. So we've got a reviews table, which links to the business table, and it also links to the users table. And in total, this data set is around 9 gigabytes. So it's not absolutely huge, but it's good enough to try out some of these capabilities in direct lake mode. So I've got this data into the lakehouse using a Python notebook. So I've used the Kaggle Python library, which connects to the Kaggle API, pulls some JSON from the API, and then it saves it into our lakehouse here. And then I converted that into lakehouse tables. Now I'm not going to be going through this code here, but if you do want to have a look at the data engineering aspects of this, then what I'm going to do is I'm going to download this notebook and I'm going to upload it into the school community. So if you do want to follow along at home with this example, then go to the school community. I'll leave a link in the description below if you want to follow along at home. And so we've got these tables here, and now what we want to do is build a semantic model that connects these data sets. We want to build some measures on top of that to kind of encode our business logic and do some calculations that we then want to visualize in a Power BI report. Okay, so here we are in the workspace, our workspace, and in this workspace we have our lakehouse. So that's the one with the 4 tables that we just saw. And attached to this lakehouse, we can see that we have 2 objects directly connected to this lakehouse. We have the default semantic model, so that's suffixed with default to indicate that that's the default model for this lakehouse. And also the SQL endpoint, right? So I just want to discuss what the default semantic model is in a bit more detail here. Every time we create a lakehouse, we get a default semantic model as well. Now, one thing to bear in mind with this semantic model is that it doesn't actually automatically update. There is a setting. If you go to the SQL Analytics endpoint and then go on settings, here we can find the settings for the default Power BI semantic model. And there's this setting here called sync the default Power BI semantic model. And by default, this is turned off. And what this means is the first time you create a lakehouse, it's just going to be an empty default semantic model, right? And then when we add new tables into that lakehouse, if this setting is off, then the default semantic model is never going to update. We need to manually sync it, right? So that's something to bear in mind. If you're connecting to this default semantic model in Power BI, and you realize it's empty, that's probably the reason. And so because of this, and for a few other reasons, what I would recommend is just to kind of avoid that semantic model default. If you want to build a semantic model, what I'd recommend is you create a new one. So what we're going to do is go into the lakehouse and click on this new semantic model. And then what you'll get is the tables in our lakehouse down here to select from. And if you can't see all of them, then you can just click on this refresh button and it brings in any new tables that you've recently created. So we can give our semantic model a name like Yelp analysis model, and you can select which tables you want to bring into this semantic model. So I just want to bring in these 3, and then I'm going to click on confirm. Okay, so here we are in the modeling view, which you'll be familiar with if you're coming from a Power BI background. And we've got our 3 tables here, and what we can do is if we just hover over them, then we can see, for example, this reviews table is using the storage mode of Direct Lake. So if you're not familiar with Direct Lake, then this is a new connection mode that we have available to us, and it's the default. So if you click on new semantic model in Microsoft Fabric, it's going to by default use Direct Lake mode. And what is Direct Lake mode? Well, you're probably familiar with import mode, whereby you bring the data into the Power BI engine, and it enables really quick read time, right? Because the data is right there when you need to read it. And perhaps you've also used direct query mode, which is whereby we don't actually import the data into the Power BI engine, but instead we send out queries to the source database. So it's mostly on databases where this is possible. And this has the benefit that it's always up to date, because when your user goes into your dashboard and needs to view it, then that's when the database is going to get queried and you're going to get fresh data every time in direct query mode. But the problem with that is that it takes a long time to get that data back, because it has to go to the database, perform the SQL query, for example, and then return the results back to you. And so with Direct Lake, we get some of the benefits of import mode and some of the benefits of direct query mode. Direct Lake is similar to direct query in that it reads directly from the data source, and our data source is Delta Parquet tables in OneLake. So how Direct Lake works is when your user logs into a dashboard, for example, and they want to look at this specific page of a dashboard, then Power BI will query the Delta Lake tables directly in OneLake and return the results very, very quickly. Now it can do that because of a number of tricks that's being done under the hood. Number one is it uses a feature called on-demand loading, which means that it's only grabbing the data that it needs for that specific view or for that specific query that's being done by the Power BI engine. So it doesn't bring back that 9 gigabytes of data every time. It only brings back the data that the user needs in that specific instance. So it's very quick. There's also some quite clever transcoding that's done on these Delta Parquet files to basically speed up that read performance. So that's a little bit about Direct Lake and what it is and how it works. And so just to underline the benefits here, the user is getting really quick read access to very, very large data sets, and they're getting fresh data, right? So there's no hourly refreshes required, no data going a bit stale. No, they're logging into Power BI and that query is generating fresh data every time. So the user is getting a real-time experience, even though these data sets can be very, very large. Okay, so let's connect up this semantic model, and we can create relationships between these tables just by dragging the keys of both tables from one table to the other. So here we're connecting from the business table to the reviews table, and this is actually going to be a one-to-many because businesses is my dimension table and reviews is my fact table. So let's just change that. Okay, and we're going to do the same for user ID as well. So from users, it's going to be one to many in this fact table, making sure that the relationships are active and you've got a single cross-directional filter. Okay, so now we have a very simple semantic model. And on top of this, we can do things like create measures, create calculation groups, manage roles, and we can also at this point save this semantic model, and then perhaps you want to load it into Power BI Desktop if you're more comfortable working in the desktop tool, or you can load it into third-party tools like Tabular Editor, DAX Studio, these kind of things as well. So for the purpose of this, I'm just going to create a quick measure. So I'm just going to create a row count on the reviews table just so that we have some DAX in there so that you can view that in the next section. Again, one thing to bear in mind is that there's no save functionality in this semantic model editor view. It saves automatically. So so you don't have to worry about that. All right, so now we have our semantic model built, a very simple one. Now we can create a report. So if you click on new report, it's going to take you through to the report creation editor. Not sure if that's the real name, but a place where you can create your own Power BI reports. Now you can see that we've got the Power BI canvas here ready to build our visuals. Okay, so now I'm going to create just some basic visuals just to show you what this looks like. I have actually included this DAX measure in the wrong table, but it's what it is. And you can see how quickly that loads, right? So I've just clicked there and very quickly it's loaded, or it's performed the count of 7 million rows and put it onto the canvas, right? So it's very quick to do that calculation. And the fact that we can analyze 7 million rows worth of data in the service online is pretty impressive, I think. So if we convert this into a chart and then chop it up by business name, now we can look at the number of reviews by business name. So there's over 20,000 reviews in this data set of Starbucks, McDonald's there's 18,000, Dunkin' Donuts, some big ones there. And so you can begin to build out your Power BI report. Now this online editor is not very feature rich, so if you're a Power BI developer, you probably want to be doing this in Power BI Desktop. And to begin editing in Power BI, well, you can first save this report. If you give it a name, Yelp model. Then once we've got our report saved, then we can just download it as a PBIF. Now what you're probably going to want to do is choose this option here, copy of your report with a live connection to the data, because we don't want to be downloading 9 gigabytes of data, and it could be a lot more than that. So generally we want to click this live connection to data online. That's going to give us this PBIX file that you can open in Power BI Desktop and continue with your report creation process. So this is what it's going to look like when you're in Power BI Desktop, and you notice we have the model view and the report view, so you can't actually do any sort of transformations on that data other than creating new measures, for example. It's similar in a way to how direct query mode works in that respect. Now I'm just going to go back to my semantic model in the service here, because I just want to point out a few configuration options that we need to bear in mind when we're looking at direct lake and direct lake mode behavior. So the first one is, if you click over to the model tab here on the right hand side, and then you click on this top level semantic model, you'll see the properties pane for that semantic model. And we can see a few different options here, and the one I want to draw your attention to is this direct lake behavior. So there's 3 different options here. We have an automatic, direct lake only, and direct query only. So this behavior is actually alluding to the fallback behavior, and this is explained in a few of the different documentation pieces that they have, and also in this article here by Zoe Douglas. And in general, what fallback means is Fabric will always try to use your direct lake connection mode and get the benefits that you can from direct lake mode, basically until it can't, and then it will fall back to direct query mode. And some of the instances of why that might be is if you've got a DAX query that exceeds the limits on an SKU, or you're using features that are not supported by direct lake, such as SQL views in a data warehouse, then it's going to fall back to direct query mode. And so what this setting does is basically configure what that fallback behavior looks like. So the automatic setting is the default, and it's going to allow direct lake to fall back to direct query if it can't execute in direct lake mode. Now direct lake only ensures that there's no fallback option. So I don't actually know what that will look like if you've got your behavior set to direct lake only, but you include a SQL view in your semantic model, for example. I presume that it's going to return an error and your report is just going to fail. And the final behavior is direct query only, which will always fall back to direct query, running all DAX queries as SQL queries through the warehouse. Now this is a really good article here because it goes into a lot more detail about what I've described, and probably describes it a lot better than I have. So I'd recommend that you go to this article here, and I'll leave a link to this in the description if you want to understand fallback behavior in a bit more detail. So now let's go back to the workspace just so we can have a look at some other settings that are quite important here. So if we go into the settings of a particular semantic model that we've got, by clicking on this ellipsis and then the settings here, we can look at some more detailed settings that we have available to us. And the one I want to point out is in the refresh section, this keep your direct lake data up to date. So this is another important setting that you need to bear in mind. So currently this semantic model is set to on, and what that means is when you change your data in one lake, it's automatically going to be reflected in that direct lake table. Now this might be what you want in some instances, but in a lot of other instances you might not want that. say for example, you've got a chain of transformations being done on a particular data set, you might not want to refresh the direct lake model until all of those transformations have been done. Otherwise, you might get a little bit out of sync. You might get some tables that have updated as soon as they're ready, and other tables might not have passed through a particular pipeline yet. So you might want to switch this one to off and then manage your direct lake semantic model updates at the end of a pipeline. And one way that you can refresh a direct lake table and a semantic model is via the Fabric REST API that you can access via SemPy, and I can leave a link to the documentation if you want to achieve that in a bit more detail as well. But that's just one method that you might use in conjunction with this refresh off button to make sure that your semantic model refreshes at the right time. Okay, and so the finished result, it's not going to win any awards, but we built a Power BI report and we built a semantic model in Fabric from lakehouse tables. And one more thing, I just wanted to point out this blog post on fabric.guru by Sandeep Pawar, and it's a really awesome article that talks in more detail about controlling direct lake fallback behavior. And this post was written in November 2023, and the part I want to draw your attention to is a new update, which is this section here, semantic link v0.7. So this is a new release of semantic link, and it gives us new capabilities to understand what's going on under the hood with direct lake data sets. So in this article, Sandeep basically walks through how we can use semantic link to understand our direct lake data sets in a bit more detail. So for example, for each data set in a workspace, we can understand what the fallback behavior is, whether it's a direct lake data set, so is it going to fall back? And these are really important things to know about our data sets in our Fabric environments. That's actually quite difficult to work out if you don't have access to this information. He's also provided some more functions that allow us to change the direct lake behavior through semantic link as well. So definitely recommend that you check out this article if you want to dive a bit deeper into understanding what's going on in your direct lake semantic models. Now in the next video, I'm going to be going into something that I think is probably the most important thing to get right and the biggest opportunity for you when you're transitioning from the world of Power BI to the world of Fabric, and that is how to get a handle on data validation and data quality. That's very difficult to do in Power BI, but in Fabric it's now easier than ever. So make sure you watch the next video where I'm going to go through that in detail. Thanks very much for watching. See you in the next one. In this video, we're going to be exploring end-to-end data validation strategies in Microsoft Fabric. Now, I think this is probably the most important thing that you need to get right when you're building that foundation in Microsoft Fabric in your data strategy. I want you to walk away with an understanding of why I think data quality should be at the heart of your Fabric data strategy. As well as that, we're going to walk through how to architect and build enterprise scale data validation systems in Fabric that give you confidence and help you build trust in the solutions that you're creating. Now to do that, we're going to be looking at why I think you should be doing data validation, what you should be validating, and more importantly, how you can validate your data in Microsoft Fabric. And to do that, we're going to focus on 3 different types of data validation that you can perform in Microsoft Fabric. The first one is going to be schema validation. So this is validation of incoming data that's coming into Fabric. So it might be files, CSVs, JSONs from REST APIs, that kind of thing. And I'm going to walk you through a demo of how you can achieve this in Fabric. Now the second one is table and data frame validation. So say for example, you want to validate the data in your silver layer of a medallion architecture. How do you go about doing that in Fabric? And again, I'm going to be walking you through step by step how to achieve this. Finally, we have semantic model validation. So this is validating our semantic models that we build in Microsoft Fabric, making sure that the relationships have been set up correctly, that your DAX measures that you've defined are returning the right outputs. And again, we're going to be walking you through a demo of how to achieve that in Fabric. Now on top of that, I'm going to be showing you not just how to validate individual parts of your pipeline, we're also going to be looking at enterprise scale data quality monitoring. So if you've got 100 data pipelines and data sets that you're managing in your organization, this is going to tell you how to monitor the data quality of all of them to look for insights about where you should be spending your time and your investment in improving the quality of your data sets as a whole. Now, this is video 6 in our series where I'm helping you make the transition from the world of Power BI to the world of Microsoft Fabric. And alongside the slides that I'm using here, I'm also going to be publishing the implementation notebooks for each data validation exercise that we go through. There's going to be 3 in total, and all of them are going to be published for free on our school community. So school.com/Microsoft Fabric. I'll leave a link in the description as well. Let's begin. So to kick us off, I just want to start by looking at why I think data validation is so important and try and get across this passion that I have for data validation, try and impart some of that onto you. Well, number one, in many industries and many businesses, regulation demands that we take control of data quality. You might get audited for certain data sets. For example, if you work in financial services is a good example, or healthcare, certain regulatory bodies are going to be auditing your data sets to make sure they comply with certain data quality standards. And in industries where perhaps you're not regulated for data quality, it's still really important as well. Because if you have really bad quality data in your organization, then your decision making is going to be impacted. You're going to be making bad decisions based on bad data. So this could incur such problems such as loss of revenue or customer dissatisfaction as well. And for people coming from the Power BI world, having poor quality data in your analytics solutions is going to lead to a loss in trust in your solutions. So your users are going to stop looking at your dashboards because they don't trust the data in them. And once they lose the trust, it's very difficult to win back. So that is why data validation is so important. Let's look at what we mean by data validation. So to kick us off, I've got this traditional data processing pipeline. We move from getting data from a source, performing some cleaning on that data, enriching it, maybe you're joining different data sets together, creating some dimensions, building analytical models, aggregations, and finally we're going to do some semantic modeling. And what I want you to think about is at each of these stages in this traditional data pipeline, what can go wrong? Because now we're looking to build data engineering systems, robust systems. So to do that, we have to be a bit pessimistic and think about what can go wrong at each stage in this pipeline so that we can build validation rule sets to try and defend against where things can go wrong. So we're going to play a little game called Pipeline Problem Bingo. And I want you to think about what can go wrong at each stage in this pipeline. So pause the video here, give yourself a minute or two and think about what can go wrong, maybe based on your experience. And then we're going to review just some examples of what can go wrong at each stage in the pipeline after this. Okay, so when we're getting new data from a data source, lots of things can go wrong. Maybe our connection details change. If you're connecting to an API, for example, maybe the token expires. We can even have things like schema changes. So if you're connecting to Azure Data Lake Storage and you're getting some Parquet files or some CSV files, maybe the data producer has added new columns or they've changed column names. And when they do things like this, it's going to impact and cause problems in your downstream analysis activities. So we want to know when these things happen right up front. Another example is perhaps you're calling an API and data doesn't get returned for whatever reason. Perhaps it's because of an API or server error and it's nothing to do with you, but you're not going to get data back from that API. Now, when we talk about cleaning steps, lots of things can go wrong here. Maybe we don't clean properly. For example, you could have null values in important columns. And important columns, by that I mean columns that you might want to join on later in your pipeline. Or perhaps you've got a really important date column that you're going to be doing a lot of time intelligence calculations on in your semantic model. So having null values in that column is going to lead to poor quality data and poor analytics downstream. Maybe the values in a certain column is outside an expected range. We've looked at date formats and data types as well. If these are wrong, then again, that's going to cause problems for our parsing and our cleaning and our transformation steps downstream. And maybe you have values outside of a predefined list. So say you're implementing metadata management and you've got a predefined list of department names, for example, and the data that you're getting from a data set includes values that are outside of this predefined list. Again, that's going to introduce data quality issues that really we want to identify in our pipeline. So when we're joining data and enriching it, well, we can introduce things like referential integrity violations. This is where the unique set in one of our joining tables does not match the unique set of the other table. So we can also have incorrect joining logic. So these could be data quality issues that you yourself, as the data engineer, you're introducing. Obviously not on purpose, but these things can happen. Perhaps you built your transformation logic and it was working, but then 3 months later, the data changes slightly and you didn't think about a specific edge case. So that's going to introduce data quality issues as well, one of which could be a duplicate primary key. And we're building analytical models. Some things that can go wrong is, well, you're implementing the business logic incorrectly. Perhaps you're doing an incorrect aggregation. Perhaps the granularity of your aggregation is incorrect. And maybe you're not handling null values correctly as well. And in the semantic modeling phase, perhaps you haven't correctly defined your relationships, you're implementing the wrong business logic, and the DAX measures that you have created aren't really working correctly for all edge cases, and it's not returning the correct values. So these are just some examples, and once you've got a lot of experience in data engineering and business intelligence, you can probably list off hundreds of things here, of things that have gone wrong in your pipelines in the past. So what we want to be doing in Fabric is thinking deeply about the data sets we have, thinking about what can go wrong, and building validation rule sets that guard us against those things. Now, if you're moving from the world of Power BI, then this whole pipeline, or at least most of it, gets done in the Power Query editor. And for each step, there's different applied steps down that right-hand side in this query editor. Now, the problem with that is that it's a bit of a black box. We connect to our data sources, we do some transformations, and at the end, we get this semantic model. But at no point can we really validate the data that's passing through these different steps. And this is one of the biggest problems that I found with Power BI. It's very difficult to assure data quality after each transformation step. Yes, you can do it once, maybe when you publish your dashboard, but what about 3 months down the line? Maybe your data changes a bit and it introduces data quality issues that you didn't think about when you were building the report, and you definitely didn't catch when you were building the report. So in Fabric, we have this huge opportunity to really get a handle on data quality. And this is what this could look like. So in Fabric, we're going to be using the same high-level data processing pipeline that we looked at before. So we're going to get some data from a source, but this time, instead of doing everything inside Power Query, we're going to write out that file into a lakehouse files area. We're going to space out our transformation steps, and at each stage, we're going to write out the results to a new location. So from our files area, we might do some parsing and cleaning, and then we're going to write it out to a lakehouse table. Then we might read it into another notebook, for example, or a Dataflow. We're going to enrich the data, join it with other data sets, create our dimensions, all that sort of stuff. And then we're going to write it out to another table. Then maybe you want to read it in and perform some sort of analytical modeling task, create your aggregations, your gold layer, and you might want to do that in your data warehouse. Then we're going to build our semantic model, and then we're going to publish our semantic model for people to consume in the form of a Power BI report. So there's lots of different advantages of doing it this way. And lots of people call this the medallion architecture. And there's a reason why it's becoming so popular, because it has a lot of benefits. Now, the benefit that I specifically want to hone in on is the fact that it makes it really easy to perform data validation, because at each point when we're writing out this data into new layers of our architecture, we can validate that the data that we're writing into the next layer of our architecture conforms to certain expectations that we have about that data set at that point in the pipeline. So we have 5, in this example, data quality checkpoints, and we can progressively assure the quality of that data set as it passes through our pipeline. Now let's just compare what we had previously. So in the Power BI example, if you're using Power Query, you're not really progressively assuring the data quality. Whereas in the Fabric example, we've got 5 data quality checkpoints. So every time we write out that data to a new layer in our architecture, the data quality is going up. So that by the end of the process, by the time we've published our semantic model and we've validated that, the user is going to be absolutely sure that they've got a lot higher quality data and it's been properly validated at each stage. So to enable this, really there's 3 different types of validation that we need to perform, and each of them are a little bit different. So The first one is schema validation, and this is validation of incoming files. So you could be getting JSON files from the REST API, it could be CSV files or Parquet files, anything like that, or data from a database, an external database that you've written into your lakehouse files area as a file. The second stage is this bit in the middle. So that's going to be table or data frame validation, Spark data frame validation. And in this stage, we're going to be validating that the transformation steps that we do between each of these different layers has been done to meet our standards. And the third one on the right-hand side there is semantic model validation. So in Fabric, pretty much for the first time, we have the opportunity to validate the semantic modeling that we do in our organization. So making sure that the relationships that we build and the DAX measures that we write are actually performing as they were designed to perform. So let's step through these one by one, starting with schema validation. So again, the core purpose is to validate that the incoming data conforms to an expected schema. That's the main purpose here. Because if the schema changes, then it's going to ruin all of our downstream analytics activities, because maybe you've got lots of notebooks and semantic models, and they expect a certain schema for that incoming data. So if the incoming data schema changes, it's going to ruin absolutely everything downstream of that. So we want to highlight this really early on. So this is what this could look like. Say you've got some incoming files and you're bringing them into Fabric into a lakehouse files area. From here, you're going to pick up those files in a schema validation notebook. You're going to perform schema validation, and then you might move the file into two different folders depending on the results of that validation. If they fail the tests, then you might move them into a failed folder, and these will get logged, and you might trigger a failure strategy. And we'll talk more about failure strategies a little bit later on. But if it passes all of our validation checks, we might move it into a passed folder, and then we're going to load it into the next layer, our raw layer of our medallion architecture. So what's going on inside this schema validation notebook? Well, we want to validate that the data types are correct, that the data structure is as we expect, and the column names are as we expect as well. We also want to validate whether the data is parsable. Can we actually parse the data that has been given to us? Because if we can't validate all of these four things, then that load into the raw zone is not going to work. Now, there's a few different tooling options available to us. Now, one of the best things about Microsoft Fabric is that it opens up the Python ecosystem and allows us to use that ecosystem on our data. Now, data validation is probably one of the best examples of that. There are so many mature data validation frameworks that we can tap into. I've just listed three here. So Pydantic, Pandera, and Great Expectations are three Python libraries that you can use to validate your data. I'll be going into a bit more detail about the pros and cons of each of these in a minute. But before we do that, I just want to focus in on Great Expectations, and I'm going to walk you through an example of how we can perform schema validation on incoming files using Great Expectations. In this video, I'm going to be explaining to you schema validation of incoming files with Great Expectation. So in Microsoft Fabric, it's likely that you're going to be bringing in a lot of files into Fabric and then parsing them and then loading them into lakehouse tables. So what this notebook is going to do is validate the schema of these incoming files. Now we're going to be using a CSV file for this particular example, customers100.csv, and I've listed the source of that in this prerequisite. So what you're going to have to do is download this from GitHub, put it into a lakehouse files area, and I put it into this nested file structure that you can either copy or you can just change the incoming file path to be validated, this first parameter here. But what is Great Expectations? Well, Great Expectations is one of the most used data validation libraries in Python. It's a very mature framework. It can be quite complex to learn. So what I've done in this notebook is try to make it as simple as possible. It's an approach that I would call GX Lite. So it's not really using Great Expectations how it's meant to be used. It's really stripping away all of the complexity and creating a really simple method for you to get started with data validation in Fabric. Now, if you want to follow a bit more of the traditional process, let's say, then I did do a video on that a few months ago. So I'll link to that here as well. And this is this one here. And in this video, I walk you through the process of setting up a data context, setting up expectation suites, setting up checkpoints, and these give you a lot more functionality. So it unlocks more advanced Great Expectations features like actions and data docs and all this stuff. But for this tutorial, we're just going to keep things very, very simple. So to get us started, we've got this parameter cell. So this is indicated with this parameters here, and we're passing in two parameters, file path to be validated and the output table name. Now I've made this a parameter cell so that you can embed this notebook into a data pipeline. We can parameterize it, so you can pass in new file paths and it will validate them as you wish. So to get started, we need to install Great Expectations. I've already done that, as you can see here, but I am going to need to, because I'm just walking you through this as a demo, I'm going to initialize these parameters here. And the first thing we're going to do is import Great Expectations as GX. Then we're going to initialize this context. So we're going to call gx.getContext. That's like an empty shell that we're going to use and we're going to pin different things to. The first thing that we're going to create is a data source, and this data source is going to be from CSV. So the way that it works is it basically reads your CSV into a pandas data frame, and from that it creates what we call a validator, and the validator can be used to perform data validation, obviously. So we call this read CSV and we pass in the file path to be validated, which is the parameter that we declared up here. Let's run that. Okay, so now that has successfully run, let's move down to adding some expectations to our validator. So when a new file comes into Fabric, in our heads, we've probably got a lot of expectations about that data set. We expect it to have, for example, 12 columns. Those columns must be named like this. We expect certain columns to have data types and they must have this data type. Now in this example, we're using a CSV file, but this method can be used for any sort of incoming file or anything coming from an API or external databases or anything like that, really. So an expectation is basically an off-the-shelf expectation that we can grab from this Great Expectations library, and you can find a full list of expectations here on this website here. I think there's about 400 pre-built that you can use, or you can create custom ones as well. So the ones that we're going to be doing, I've declared 4 expectations here. Now this is by no means exhaustive. So the first one is to expect that the table columns match this set. So I've declared this list of column names and they must match this, otherwise the expectation and the validation is going to fail. I've got 2 expect column values to not be null, and I've passed in the column ID, and the column ID is going to be the primary key of this table, and we're going to use this to link to other tables further downstream in our data processing pipeline. So it's important to know that there's no null values in that column. The next one is subscription date. And this could be a really important column for some downstream analysis task that we've got planned. So maybe you're doing some time intelligence calculations on this that are really important, and you need this column to not be null. The final expectation is that column values match this specific datetime format. So passing of datetimes from strings is something that can go wrong. So here we're just double checking, again, this really important column on subscription date matches this expected format of year, month, date. So again, if that changes, maybe we get a new data set and it doesn't have that date format, then again, our parsing of that is going to fail. So we want to understand when that date time format changes. Let's run these. And by running them, all we're doing is we're adding these expectations into this validator object. Okay, now this has finished running. We can see the output of the last one there, and it's basically this object that shows success equals true. So the last validation test has passed, and it gives us a bit more details about, okay, we've had 100 rows of data and all of them passed. So next what we're going to do is called validator.validate, and this is going to run through each of our expectations based on the data that we provided in this file, and it's going to return this validation results object. So let's just inspect that, just have a look at what that looks like. Okay, so it's returned this object, and kind of the first key here is success equals true. So if all of your expectations pass, then you'll get a success equals true. Then if you want to inspect individual expectations, then we get this results list, which has for each expectation the individual result. So the first one was true, and this was when we expected table columns to match the set. So all of the table columns did match the set, and it does this for each individual one. So it just goes through each of our expectations and gives us success equals true. So finally what I've done is just a little section on handling the results, so parsing that validation results object. And here I've just defined a few functions that basically just helper functions. One of them is to write data to a lakehouse table, move a file to a folder, write validation results centrally. Now those were just helper functions. These are bit more important functions. So we've declared a handle success function and a handle failure. And then what we're going to do is, if validation.results is successful, then we're going to run handle success. And in this function, what we're going to do is move the file to a validated folder, write the validation results to a central lakehouse for logging, and then write the data, the actual real data, to a lakehouse table. So if all the validation results are positive and it passes the validation results, then it's going to run through these different things. And this is just a sample of activities and actions that you can run on a successful validation run. Very much depends on your business and what you want to do, but it's just to give you some ideas. If it fails, then we're going to, again, write the validation results centrally. Maybe you want to move that file to a failed validation area in your lakehouse files area, for example. So let's just run that. So we can see that it's printed past validation, and now it's running the Spark jobs in progress. So our Spark jobs are in progress, so it looks like it's writing something to the tables, and they've succeeded. So if now we just refresh this, here we have a raw customers table. So we've validated this incoming data set, and we've written it into a raw table in our lakehouse. Next up, we're going to focus on table and data frame validation. So that's this bit in the middle. And here we're trying to validate that the structured data, so the tables and the data frames that we have, normally after some sort of transformation, that they meet certain expectations in terms of data quality. Now, this is going to be highly dependent on the data set. You're going to have to use a lot of domain knowledge here, and also the different stages in the pipeline. So let's look at that in a bit more detail, what that looks like. So say, for example, you've got some data in a raw table and you want to do some cleaning on that data. And then after you've cleaned the data, you want to perform validation that it meets certain requirements. So you might do some cleaning and validate the output. And then if it's successful, you might write it to the next layer in your pipeline. Now, if it fails, you're going to want to log it and then trigger the failure strategy again. So what's going on inside this notebook? Well, really it depends a lot on your data and also your downstream analytics tasks. But typically some things that you might want to check here, as we mentioned previously, that you'll be checking that there's no null values in what I'd call important columns. And this is again based on your domain and your data sets. Checking that values are in expected ranges is an example of what you might do at this stage. Checking that categoric variables are in some predefined list, and also that data sets that need to be deduplicated have been, and that primary keys are unique. So the tooling for this stage is a little bit different. So yes, we can still use Python and Spark. So we can use Great Expectations or Pandera. But another option here is to use SQL and specifically dbt. Now dbt is a third-party library that we can connect to our data warehouses in Microsoft Fabric. And it's built really to do that transformation piece. So we can transform tables between different layers in our architecture. And we can also build into our dbt scripts data validation. So that kind of comes with dbt. It's a core part of dbt. Let's have a look at what that might look like. So if we're using dbt for this transformation between different layers in our medallion architecture, say for example you have a raw data warehouse and a cleansed data warehouse, and we want to use dbt to do that transformation and then validate the results when we're writing it into the data warehouse. So this is what that could look like there. Now I want to show you what this cleansing and validation notebook would look like if we wanted to use Python and Spark and Great Expectations. So let's dive into the example of how you can achieve data frame validation in Microsoft Fabric using Great Expectations. Okay, so here we are in our second notebook, and here we're going to walk through Spark data frame validation with Great Expectations. So in the last tutorial, we looked at how to validate incoming data in files. Next, we're going to look at this middle section. So here we're going to be validating Spark data frames. So say, for example, we have performed some cleaning and parsing of a lakehouse table, and now we want to validate that that cleaning has been done successfully and it hasn't introduced any errors, and all of the expectations that we have about that data set are correct, so that we can write it into the next layer in our pipeline. So this is what this looks like here. Now again, this approach uses Great Expectations, and again uses an approach what I would call Great Expectations light. So it's not using a traditional workflow that you might use with Great Expectations. It's specifically designed to be easy to understand for beginners, to help you get started with data validation and with Great Expectations in general. So the prerequisites for this notebook Well, it assumes that you have run the first notebook and that you have a lakehouse table called raw customers. So that's the one that we wrote out in the first notebook. We've also got this parameter cell. So we've got two parameters. We've got the table name to be validated, which will be raw customers in this example. But again, these are parameterized, so you can embed this notebook into a data pipeline to parameterize it. And I've also passed in a output table name as well. So let's just run those. Next up, if you haven't already, you'll need to install the Great Expectations library into our notebook. What we're going to begin with is getting some data from this lakehouse table. So here I'm just using Spark SQL, and we're going to select star, so we're getting everything from this table, and we're passing in the table name to be validated, and we're saving it into this DF, Spark Data Frame object. Next, we're going to call some passing and cleaning function on this data frame. Now, this function is just not doing anything, but for the purposes of this notebook, it doesn't really need to do anything. This isn't the point of this notebook. It's just to show the validation side rather than the passing and the cleaning side. So let's run this. So that's successfully finished now. The output of it is this clean DF. So that's going to be what we carry forward into the validation step. Okay, so now we're going to define a set of expectations similarly to how we did in the first tutorial, but we're going to initialize our Spark DF dataset in a slightly different way. So we're going to import Great Expectations as we did previously, and next we're going to use this dataset.sparkdf_dataset, SparkDF dataset class, and we're going to pass in our cleaned DF, and this is going to initialize an object of type Spark Data Frame dataset, which is a Great Expectations object, and that's going to allow us to attach all these expectations and run the validation similarly to how we did previously with the pandas read CSV object. So in this example, again, we've defined some expectations, and these are again very dependent on your domain and the dataset and the downstream analysis activities that you're going to carry out with this dataset. We're expecting that the column exists, so subscription date exists. We're expecting that the column record creation date also exists. We're expecting that the values in this subscription date column are greater than this specific value. So this is very much based on domain experience. Say you know that the subscription date for this dataset is from a particular product that a customer's just started using, and this product wasn't launched until the 1st of January in 2020. So any dates prior to that date, we can assume are erroneous. Similarly, we've got another one for greater than now. So any subscription dates that are in the future, and again, this is very much dependent on your domain and your data set, whether this makes sense, but just to show you how it works, if the subscription date is in the future, then I'm going to assume that that is also erroneous. And the last one is matching a regex, regular expression. So it's just to check that the email column is a valid email. Let's run these. Okay, so that has succeeded. Next, let's run to the validate function. This works in a very similar way to what we saw previously. We're going to validate all of our expectations that we've assigned to this GXDF object, and we're going to return some validation results. And again, we've done some handling of those results. So here we've got a function that writes this Spark data frame to a lakehouse table. So if all of our validation tests have passed, what we're going to do is write it out to a valid table. So here we are with the handle success and the handle failure. It works in very much the same way. Here I've just written one success action, which is to write out this table into a new table for valid data. Okay, so all of those Spark jobs have now succeeded, and if we refresh this table, then we'll see that we've got validated customers. Now, in practice, you might want to save your valid data into either a different lakehouse or some area differently, depending on your data architecture and your data strategy. But for the purposes of this demo, I've just put them all in one lakehouse to make it easy to follow. Now, the third type of data validation that we can do in Microsoft Fabric is semantic model validation. And by that, we mean validating that the semantic information that you define in your semantic model, so the relationships, any calculations that you've done, any DAX measures that you've created, that these have been correctly implemented and they return the correct results. So this is what this could look like. So say, for example, you have a data warehouse, your gold layer, and you're bringing in some data sets into a Power BI semantic model. You're performing your Power BI report development process, and the output of that is going to be a report and a semantic model. Now, before the user lays eye on that report, what we want to be doing is validating that semantic model. And to do that, we can use semantic link and great expectations. Now, semantic link is a feature in Fabric that allows us to basically inspect what's going on inside a semantic model through a Python notebook. So we can have a look at the data in tables in the semantic models. We can explore relationships. We can even evaluate DAX measures and inspect the results. So the combination of that plus great expectations means we can validate that what's gone on in that semantic modeling phase actually reflects reality, and you've encoded the right business logic and the calculations are returning the right results. So just to summarize what we've been through here, at this stage we're going to validate that the DAX measures that we've created return the correct values, and that the semantic relationships between tables have been correctly defined. The tooling, as we've mentioned, is going to be semantic link in a Python notebook plus great expectations. Now let's look at an example of how you can achieve that in Fabric. In this tutorial, I'm going to show you how you can perform semantic model validation with great expectations in Microsoft Fabric. So the goal here is to validate that the semantic modeling that we've been doing, so building relationships between different tables, our measures that we've defined in our semantic model, and the table data that we have in our semantic model conforms to certain expectations that we have. Now, Microsoft themselves have actually published a sample notebook to show you how to perform semantic model validation in Fabric using great expectations. It's actually very detailed and it steps you through the process of setting up a data source, your context, your expectation suites, adding different resources into these data sources as well. So this is a good resource to understand a little bit about how to do this in a more proper way in Great Expectations. Now, the approach that I'm going to be using is a little bit different. I've tried to make it as simple as possible for you to start using data validation on your semantic models. So let's have a look at this approach in more detail. The notebook assumes that you have run the first two notebooks and you've created a semantic model in your workspace. Now, I've called mine my semantic model. This is what it looks like. It's very, very basic, just to show you the data validation piece really. And in my semantic model, I have one table, and I've also created a measure here called number of customers, which I think is just the row count of all of the rows in this table, but it's good enough for this example here. So you're going to need to install Great Expectations and also this time semantic link. So semantic link is what we're going to be using to extract that data from our semantic models and make it accessible with our Python code. So once you've installed both of those, we're going to look at how you can validate three different things in your semantic model. We're going to start by looking at validating the table data. Then we're going to look at validating the measure outputs, so outputs from any measures that you've defined. And then finally, we're going to validate the output of some DAX queries. So starting at the top here with table data. So say, for example, you've done a lot of cleaning in your Power Query engine in your semantic model. Here we want to validate that any cleaning steps that you've done within Power BI itself have been implemented correctly. And this is going to be really simple here. So all it takes really is 4 or 5 lines of Python. So we're importing Great Expectations, we're importing senpai.fabric, so that's that semantic link module. Now we can tap into fabric.read table to get any data set that exists in our semantic model. So we're going to pass in the dataset name, so that's your semantic model name, and your table name, and it's going to return a data type which is a Fabric data frame, which inherits from the pandas data frame. And that is really important because we can use the Great Expectations functionality for creating a validator from a pandas data frame. Now, Great Expectations does actually have some integration with Fabric built already. And if you look at the Microsoft supplied examples, you can use things like when you're adding a data source dot add Power BI underscore DAX asset, or for tables, it's ds dot underscore Power BI table assets. Now, I'm not actually using this approach. I'm basically hacking the system and benefiting from the fact that this function here returns a pandas-like object, and this makes it really simple to just add gx.fromPandas, and that's how we're going to create our validator in this case. And it's the same for all the other examples. So all of these functions return a pandas-like data frame, so we can use exactly the same logic here. Next, we're going to follow exactly the same process that we did in the last two tutorials. So once we've got this validator object, we can assign different expectations to it. And in this example, I've just done one very simple expectation, but obviously in practice, you're going to want to think about how you want to validate that semantic model in more detail. Then we call validator.validate and we return this validation results, and that results object is the same as we've seen in the last two videos. So if we run that, we should get a success equals true. In the next example, it works very, very similarly, but we're actually using a different function in the SemPy library. The goal here is to validate outputs from any measures that you define in your semantic model. And we're going to call fabric.evaluate measure, and we're going to pass in the measure name. So here we've only got one measure in our model, which is number of customers. And again, this is going to return a fabric data frame, which is very much like a pandas data frame. And so we can pass it into gx.fromPandas. And that's going to return us our validator that we can assign expectations to. Now in this example, I've done an expectation that the column value is to be 100, basically, because I know that there's 100 rows in this data set. It doesn't really make much sense in the wider scheme of things. It's just to show you the functionality. Finally, we've got validating DAX query outputs in a semantic model. So here you can define a DAX query in a string, and then you can pass it into fabric.evaluate DAX. That's going to return a fabric data frame again. And again, we're going to pass it into gx.fromPandas. Now in this example, I'm expecting that the column values are between 1 and 6. Again, it's just a toy example of an expectation. I'm more interested in showing you how to bring together semantic link and great expectations. The actual defining of the expectations is down to you, based on your domain knowledge and your expertise in your datasets. So that is a very, very simple way to validate semantic model information using great expectations in Microsoft Fabric. So next, I just want to step into a bit of a wide review of tooling and approaches. I've mentioned quite a few tools up until this point, but now we're going to do a bit of a side-by-side comparison so that you make a good decision for your business. And we're going to be comparing against a few different criteria. So we're going to be looking at which language it uses, the relative difficulty of that approach, whether I think it's suitable for kind of an enterprise scale solution, the cost, if that's relevant, and any other notes about that particular approach. So I think it's worthwhile starting with code your own as a bit of a baseline, because it is possible to write data validation rule sets. If you know Python or SQL, you can write your own. Now the difficulty here is quite high, at least to write good ones. And I would argue that it's difficult to scale to an enterprise level. There's lots of features that we get with some of the other things on this list that you will have to code yourself. And you're not taking advantage of the huge ecosystems, the mature libraries that already exist for data validation. For example, Great Expectations has about 400 different data validation rule sets that are probably going to cover 95% of your business's use cases. And you can just get those out the box, off the shelf. And that's going to save you a lot of time. And this code has been battle tested with millions of users, so I definitely recommend not to code your own. So next we have 3 different Python libraries for data validation. So if you are comfortable using Python, or people in your business are comfortable using Python, these are just 3 tools that you can use. Now, it's by no means definitive, this list. There are lots and lots more data validation libraries in Python, but the first 2 are Pandera and Pydantic. Pydantic, I think, is one of the most popular data validation libraries, very common in the data science world. And these are quite easy to get your head around. They're quite straightforward. They do pretty much exactly what you expect, and they're quite quick to learn. But the problem with them is that, in my opinion, they don't really scale up to an enterprise scale solution. They're good if you're a data scientist and you want to validate individual data sets, but there's no real functionality for enterprise scale logging. They don't have a common format for writing validation results that's very important, and we'll go into the reason why in a minute. But they are free as well. So all of these Python libraries are open source. Great Expectations is slightly different. So with Great Expectations, it's a very mature and wide-ranging, feature-rich library. You can do a lot with it. But what goes hand in hand with that, it's actually quite difficult to learn to a good level. There's a high learning curve, let's say. But a lot of these features are useful if you want to do enterprise scale data quality monitoring. We have features like writing out your validation results. There's data docs, which automates the creation of documentation for each of your data sets that you're validating. We have a really huge library of pre-existing expectations, and you can even configure it to give you a list of actions that you need to rectify data quality issues in your organization. So it's definitely the most feature rich, but also the most difficult to learn and implement. So next up, I want to talk about SQL. So if you prefer using SQL and you want to perform data validation, there's a few different options again. One of them is to code your own with SQL stored procedures. But again, I maybe wouldn't recommend that because it's going to be quite difficult to implement and it's difficult to scale. You're going to have to write your own logging. It's going to be difficult to build robust validations, and everything you do, you have to code your own. Now, if you are going down the SQL route, then dbt is a really good tool for performing data validation. And again, you get a lot of enterprise scale features as well, like documentation. You also get really good validation results. All of this stuff comes out of the box with dbt. Now, there is an open source version of dbt, but you're probably going to be wanting to use the cloud version of dbt if you use dbt, which does come with quite a hefty cost. So bear that in mind. Finally, I just wanted to mention DAX, because DAX can be used to validate data. I've seen some examples of people trying to validate their data sets with DAX. And again, this is not really something I would recommend because now we have the benefit of the Python ecosystem. For me, it makes more sense to tap into that pre-existing ecosystem with very mature libraries for doing data validation. And obviously the problem if you do DAX, you can only really validate that semantic modeling piece. You can't validate incoming files. You can't really validate Spark data frames either. And that's going to cause an issue in a minute on the next slide. So up until this point, we've looked at various stages in this pipeline and which tools we can use for individual parts of that pipeline. And this represents one data set flowing through your system. In reality, you might have hundreds of pipelines like this. So how do we manage and monitor all of these pipelines across your organization? How do we get that picture across your organization to understand where the data quality issues are rising, where the trends are, where do we need to spend more of our time and our investment in improving data quality across our organization? Well, now we're going to walk through how you might achieve that. So let's just look at that medallion architecture that we've been discussing in a bit more detail, where on the left-hand side, you've got files coming into Fabric, you've got various layers of lakehouses, and then at the end, you've got some sort of semantic model that you're going to be using for data visualization, showing to your business users. Well, one option here is to use Great Expectations to validate every time you move data between various layers in your lakehouse. Now, it's important to note here that Great Expectations is one of the only tools that can perform validation at each of these different stages. So we can use it for file validation right on the left-hand side, and we can also use it for semantic model validation, and of course Spark data frame validation in the middle. And this becomes important because every time you validate something in Great Expectations, we get given a set of results that is in the same format. And so when we get that, we can write out those validation results into a central data quality lakehouse. So we're going to build up this record of every time something gets validated in our organization. Now this is going to become a very useful and valuable data set. And from this, we can build a data quality monitoring report in Power BI that looks at all of these results as they're coming in. We can also make use of a feature of Great Expectations called Data Docs. I think I mentioned that previously. That's going to automatically generate documentation based on the validation tests that you write for each data set. Now, this is going to be a really important and valuable resource as well, especially for people that enter your business. Say you can give them the documentation for your data. They can see every data set you've got in your company and how it's being validated. So they're going to see the specific columns. If you've done the data validation correctly, they're going to understand the specific columns that are most important for each data set and how they're going to be validated. And from that, you can build up a really good picture about what is important in your company. So the key point in this kind of enterprise scale monitoring of data quality is that it really helps if you only use one tool for data validation. So it makes sense to choose one tool and just use that. And the reason is because it's going to output validation results in exactly the same format, and then we can combine those in a central lakehouse. Now for that, I recommend Great Expectations, because out the box, it can handle all three types of data validation that you might want to do in Fabric: your source files, your tables in the middle, and your semantic models. And a central logging lakehouse centralizes all of these validation results for every checkpoint and every pipeline. And on top of that, you can build data quality monitoring reports in Power BI. And you can make use of the data docs functionality to document all of your data sets that you're validating. And that again can be written to a lakehouse, and you can build a Power BI report that's like the documentation for all your data in your business. So finally, I just want to touch on a few other features that we can integrate into this data quality monitoring system that we're building. The first one is around failure monitoring. So say we implement this sort of architecture here, and we have our data quality monitoring report in Power BI. Well, we can use a new feature in Fabric called Data Activator. And what that's going to do is it's going to monitor the data that's flowing through that data quality report, and it's going to check for certain conditions. So we can build Data Activator reflexes that look for validation failures in any of our pipelines. And when we spot a validation failure, we can trigger notifications, Teams messages, or even Jira tickets that automatically get generated from those failure events. Now, why is this so important, all of this? Well, if you work for a consultancy and you have your client ringing you up saying, this dashboard doesn't look quite right to me, I think there's a problem with data quality. Really, you want to be in a position to say, yes, I know, we've seen that it's failed validation checks, and we're already working on a solution to get that recovered. Rather than, oh, I didn't know about that, we'll definitely check that out and we'll get back to you in a few hours when we find out what's wrong. It puts you in a much more proactive and positive light if you can say truthfully that you already know there's data quality issues and you're acting to resolve them. And this alerting feature is going to help you do that. So another feature that we can tie into in Fabric is the data governance, and specifically the certification feature. So say, for example, you've got your gold warehouse. Well, by the time it reaches that gold warehouse, we can be very sure that the quality that we've got in that warehouse is very high. We've probably validated it several times by that point. And so we can certify that gold lakehouse and say that any data that lands in that gold warehouse, it's certified, you can use it for whatever you want in your organization. And we can also do the same for semantic models. Now, to enable endorsement, you can go to your warehouse settings, go to the endorsement setting, and then click on certified for that specific warehouse. And you'll need to enable that in the admin portal if you haven't already. Now, one thing to point out here is that you can specify a URL to the documentation page for certification. And this could point to that data docs dashboard that you've got generated via Great Expectations. So just to summarize here, what are the next steps that you can implement to embed data quality and data validation in your organization? Well, it starts by putting data quality right at the heart of your Fabric data strategy. I think this is so important that you really get a handle on data quality, really as the foundation for everything that you do in Fabric. Before you start looking at fancy LLMs, machine learning, amazing visualizations in Power BI, I would argue that it's much more important to get a handle on data quality and progressively assure the quality of each data set that passes through your architecture. And to do that, you need to design the right architecture specifically for data validation. So you don't really want to be thinking about data quality and data validation as an afterthought. Really, you need to be thinking about it when you're architecting your company architecture. Then you want to think about, okay, what do we need to validate at each stage in your pipeline? And this is very dependent on your domain expertise, a really thorough understanding of your data sets, and also an appreciation for what downstream analysis activities you're going to be doing on each data set, and more specifically, each column on that data set. You're going to want to choose the right tool for the job. Then you're going to think about setting up enterprise level monitoring. So not just individual pipelines, but how we can pool all of that data and start to generate insights about data quality in your organization. You're going to want to design and implement a failure strategy for your data validation routines. So agreeing a process for how you're going to deal with when things fail. And finally, you can tap into the other Fabric features like data governance and certification to prove to your organization that these data sets have been validated and you certify that they meet certain standards in terms of data quality. If you made it this far, thank you very much for watching. Let me know you have with a green tick emoji in the comments. It really means a lot to me. All of the notebooks and lesson notes can be found on the school community absolutely for free. So go down there, school.com/Microsoft Fabric. Now in the next video, we're going to be doing an end-to-end project in Microsoft Fabric, showing you how to migrate from Power BI to Microsoft Fabric. We're going to be walking you through all of the different decision points that we've gone through in this series. So setting up your environment, getting data into Fabric, choosing a data store, building a semantic model with Direct Lake, and then validating the whole solution in an end-to-end project. So make sure you join us for that. I'll see you there. Hey everyone, and welcome back to this series where I'm helping you transition from the world of Power BI to the world of Microsoft Fabric. Today, we're going to be looking through this document here. I've produced this and it's 9 pages long, and it's specifically to give you guidance for designing end-to-end data solutions for your organization in Microsoft Fabric. Because what I've found is that there's two kind of coexisting observations. Number one is that there are infinite different ways in which we can configure Microsoft Fabric. It's a very, very flexible tool. There's lots of different options at each stage in your data pipeline, whether it's getting data, storing data, serving data, building semantic models. There's lots and lots of different options. And I would say that there's no real best way of using Microsoft Fabric. Really, it's dependent on your organization. Every organization has different requirements. Your data is stored in different locations, different source systems, each with different security kind of configurations. You've got different budgets, different skill sets in your teams. All of these things make it really difficult to kind of prescribe one architecture that you should follow. I have a lot of people in my community here on school.com/Microsoft-Fabric. They're asking me, what do you think of this architecture? And it's quite difficult to provide advice without really understanding your business, because you need to understand the specific context of your business to be able to make good architectural decisions. So the original plan for this video was to build an end-to-end project that drew together all of the lessons learned from the last 5-6 videos. But when I was planning that video, I thought what would actually be a lot more valuable for you if you're planning out end-to-end architectures in Microsoft Fabric is to come up with a decision-making framework that you can apply to your organization. And what this document is a list of 36 questions that you can ask of yourself and of your team and of your organization that's going to help you think about the right things when you're designing data infrastructure in Microsoft Fabric. So this document provides some of those questions. It's not meant to be exhaustive. It's just a bit of a guide about some things that you should consider at each stage when you're planning out your solutions. There's probably many areas that I haven't covered. And if you can think of something very important that I haven't covered, then leave a comment below and I'll definitely add it in. I'm thinking of making this kind of like a live document. So as kind of new information comes in, new features are released, or best practices start to emerge, then I'll be updating this document as well. Now you can download this document completely for free. It's on the school community and I'll leave a link in the description. As with all of the videos in this series, I've got resources and things that you can follow. Like here's the PDF for this module. Direct Lake mode, it's got an IPython notebook that you can download. The validation series had a number of notebooks as well. And when I launch this one, it will include this PDF completely for free, so you can use it in your organization. So the document is structured following the similar structure to how this series has been structured. So it's going to step you through a logical kind of path of decisions that you need to make. Number one is around structuring your tenant. So thinking about capacities, workspaces, security, access control, and that stuff. Then we'll look at getting data into Fabric. And for each of these, we're going to be looking at a number of questions. So between like 3 to 10 questions for some of these sections that you need to ask yourself. Storing data in Fabric, building semantic models, and validating your data and semantic models. So let's start with structuring your Fabric tenant. So this is going to be the first thing really that you need to get right when you're designing a new architecture or a new solution in Microsoft Fabric. This is just the sample capacity and workspace design from the documentation. And one thing to note here, I'm going to be going through these relatively quickly because there's 36 questions in total. So I want to do 30 seconds to a minute on each just to make sure that the video is kind of not too long. Now, each of these I've mentioned in detail in my previous videos, and where relevant, I've tried to link to that specific point in the videos earlier in the series. So if you want more information, you can look at those videos there. So let's start with number one. Do you have requirements to keep data stored in a specific geography? For example, to comply with GDPR. So if you have customers, you need to keep their customer data within the EU, for example. The capacity is what defines where your data is stored. So if you create a capacity in West US, your data will be stored in West US. If you create another capacity in Paris, France, your data will be stored in Paris, France. And obviously this has a pretty big implication over complying with regulations. So you need to get that right. Do you want to separate your data processing, kind of data intensive stuff with your Power BI reporting? So if yes, then you might want to have separate capacities for these as well. And what about billing? Because billing can have an impact on the capacities that you design as well. So in some larger companies, they might want separate capacities for different departments so that they can have like ring-fenced budgets for this department. Maybe a finance department is going to have a separate capacity and they can be billed via the finance department, whereas your consultancy division might have their own capacity that they can use. And obviously these capacities can have different SKU, different levels of resources assigned to them, and therefore different costs associated with them. Now the next one is, what is the planned intensity of your workloads? And are you willing to wait for the completion of certain workloads? So the SKU level of your capacity determines the amount of compute resource that's available to you. So data intensive workloads like ingesting a lot of data, high volume of data, or training machine learning models for like 4 hours or more, that's going to use up a lot of your compute resources. So if you're on an F2, it's going to start throttling your capacity. It's going to make it very difficult to use if you're doing a lot of these intensive workflows. So if you do have kind of data intensive workloads, you've got a lot of data, then you're going to be wanting to use one of the higher capacities to crunch through that data in a lot shorter time to free up your capacity to do, I don't know, report serving or anything else that you want to do in your capacity. Next, we move on to workspaces, and workspaces is a bit complex. This is probably the area that there's the most kind of creativity or different ideas about how you should architect different workspaces. So some guiding questions when thinking about your workspace design are, which groups of users need access to which Fabric items? So as I mentioned, the workspace is the primary way that we can restrict access to items in Fabric. So it's worthwhile thinking about who needs access to what, and create logical groupings of people like your data scientists, your data engineers, your BI analysts, your BI consumers. Think about grouping like personas in your organization, and then perhaps creating workspaces for each of these groupings, or at least giving access to workspaces based on these groupings. Do you have requirements for separating dev, test, and production workloads and the data stored in data stores as well? Because this is going to have an impact on your workspaces. You might want to split out different workspaces for dev, test, and production. And relating to the above, do you have any requirements for version controlling your Fabric items using the Git integration? Git integration is done at the workspace level, and then you kind of select items within that workspace that you want to be source controlled. But it's done at the workspace level, so that can affect your workspace strategy. There's more information in this link here. Now, finally, one thing that we mentioned in our video on capacities and access control was around data pipelines. So if you're going to be using data pipelines, then you need to be careful when you consider some of the constraints that exist around cross-workspace reading, writing, and triggering other notebooks, store procedures, all of that kind of stuff. And I've linked to the specific section in the YouTube video where I've mentioned that in more detail. Next, we move on to security and access control. So this is obviously very, very important. This is the high-level representation of the Fabric security architecture, linked from the documentation. So what are some of the guiding questions that you need to ask yourself around security and access control? Well, we've touched on this a little bit previously. What are the core groups of users who need access to your solution? The core groups of users. And as we mentioned, it's always a good idea to create Entra ID security groups that manage your access via groups rather than giving individuals access to a workspace or individual items, because this can get very messy very quickly and it's difficult to manage and maintain. Do you have requirements for row level security? Now, row level security can be managed at the data warehouse level, but propagation to kind of downstream items is currently working on that feature, that capability. It's what's called one security, and that's coming soon in Microsoft Fabric. So just bear that in mind if you're considering row level security. You're probably going to be thinking, where do I do row level security? Is it in the data warehouse, or is it in the semantic model, which you might be familiar with already? So that is a bit of a question mark currently around one security, and they're going to make that a lot clearer soon. Now I've put a bit of a catch-all here, like do you have data stored behind firewalls and virtual networks, accessible via private endpoints, all this kind of stuff. Now in the last few weeks, Microsoft released a lot of features around this kind of security and accessing private data behind firewalls to help you access this data from inside Fabric. And I haven't mentioned a lot about that yet on the channel in this series, but if that is your situation, your requirements, then there's a lot of really good documentation here that you can follow. Just goes through to the security page, which is kind of the top level page, and then underneath this there's a lot more information about how you can do all of these different things if your data is secured, maybe in Azure or different cloud services or even on-prem services as well. So next we're going to move on to getting data into Fabric. So some initial guiding questions here really. Depends on where your data is stored. So is your data stored in ADLS Gen 2, Amazon S3, Google Cloud Storage, or the Dataverse? And if yes, you can use shortcuts. If your data is stored in Azure SQL Database, Snowflake, Cosmos DB, then you can use the new feature database mirroring. So that's only released this week at the Fabric conference in Las Vegas for public preview. So that's an option if your data is stored in any of these three. Is your data stored on-premise? So if so, you can use either Dataflow with an on-premise data gateway, or you can use the new data pipeline on-premise access feature functionality that again they released only a few days ago at the Fabric conference. And I've linked to some documentation about how you can achieve that as well. Are you ingesting real-time event data? So if that's the case, then you can use the event stream. Now these four cases are ingestion methods or ways of getting data into Fabric that have specific features designed for them to make it easier. Now if you've got data living in any other system, then you're going to want to be doing plain old data ingestion, ETL, right? And to do that in Fabric, there's three main tools. So there's the Dataflow, Gen 2, the data pipeline, copy activity, and the Fabric Notebook. Now choosing between these, which one you want to use, is dependent on these questions. So you might want to consider if you already have pre-existing Power BI Gen 1 data flows, then it's a fairly easy process to kind of port over that logic into a Dataflow Gen 2. And there's a tutorial on how to do that linked here. And related to the above, what's the current skill level of the people in your organization who will be creating these ETL items? If it's predominantly no or low code users, then probably going to want to be using data flows or data pipelines. If you have data engineers who are comfortable using Spark, Python, Scala, those kind of languages and frameworks, then you're probably going to be wanting to use a combination of data pipelines for the orchestration part and Fabric notebooks for the transformation part. Another one I put here is, are you going to be connecting to REST APIs with complex authentication or pagination or all of these kind of more complex APIs that we can interface with? And if it's yes, then it's probably best to use a Fabric notebook because you can get really good control about where you're passing tokens and when you're passing them. So I'd definitely recommend that for REST APIs. Another consideration is the data accessible using a Python client library? So some of the big SaaS providers like HubSpot, they have Python client libraries that you can use to really easily authenticate with their APIs and their data, and it kind of abstracts away the logic. You just authenticate with their client service and you request a data set in one line of Python. So if that's an option, if you're using a SaaS provider that has a Python client library, again, you can do that within a notebook. Now the final one I put here about getting data in is, do you want your ETL jobs and your items to be version controlled? So this is now available for the data pipeline, and I've linked to where you can learn more about that, but it's not currently available with the Dataflow. So if you want to be really tightly version controlled on your ETL stuff, your data pipelines, it's possible now with your data pipeline. Dataflow, I'm sure, will come in the future. Notebooks, you can also version control as well. So next we move into choosing a data store, and I did a long video about this as well. So if you want more context, then go to this video here. But once you've selected a strategy for getting data into Fabric, you need to select where you want to store it in Fabric. And there's three choices. There's three different data stores that are available to us: the lakehouse, the data warehouse, and the KQL database. And as with all these things, there's pros and cons of each, and they're designed for slightly different use cases and slightly different personas in your organization. Now, a few questions to get started when selecting an individual data store for a specific task. Well, is your data structured, or is it semi-structured or unstructured? So is it in tables, CSV, JSON? Is it image data? Is it audio data? The lakehouse files area is the only location in Fabric where you can store files. So semi-structured or unstructured. So if that's your requirement, you're going to be wanting to use a lakehouse. And typically a lakehouse is used to get these files from external systems, then transform them and load them into some more structured format into a lakehouse table. If you're storing real-time event data, then you're going to be wanting to store that in a KQL database, at least initially. Now you can route that data into a lakehouse as well, either at the same time or after the event for more long-term storage, and if you want to integrate it better with Spark for kind of machine learning, time series forecasting, all of that kind of stuff. But at least in the kind of the bronze layer, you're going to be wanting to use the KQL database. Now, number 24 here is what are the skill sets of your team? So if you're predominantly SQL based, then the data warehouse is obviously your best bet, which is a transactional data warehouse. If you have Python or Scala data engineers, then the lakehouse offers a lot more flexibility for you. And related to kind of the skill sets is, do you want to make use of the low and no code functionality and features available in Fabric? Because in the data warehouse, you have visual queries that you can use for data transformation, data querying, and that's one of the easiest methods. The data wrangler is another feature that's available in Python notebooks, in Fabric notebooks, so they can interface with your lakehouse data. Now this basically gives you some code in a no/low code way. I would still argue it helps to know a bit of Python to understand what that code is then doing before you execute it. But that's another option if you want to use the data wrangler and you want to use Python in notebooks. Finally, we're going to look at the version control point again, because this is where some of the data stores differ slightly. So the lakehouse and any notebooks that you create can be Git controlled. It can be integrated with a Git system. Currently, it's only Azure DevOps, Azure repos, but they are introducing GitHub integration soon. So currently, Git integration is not available for the data warehouse, although this should be coming soon, I imagine. And you can actually achieve something similar if you set up your data warehouse and you manage your data warehouse through a SQL project. So that was looking at individual data stores. How do we select the right one for the right job? In practice, what you're probably going to be wanting to do is create more than one data store and combine them in some sort of coherent architecture. So here's some of the questions that you should think about when you're combining multiple data stores into one architecture. Are you planning on following the medallion architecture? So typically here, the bronze layer in Fabric will be a lakehouse. If you're going to be dealing with flat files, CSV, JSON, all of that kind of stuff can be stored in the files area, and then you can transform it into the lakehouse tables area. Now it is possible to not use a lakehouse for the bronze area, but you'd have to do all of your transformation before you load it. So you can query a REST API from a Dataflow, for example, or a data pipeline using the web activity. And then you can perform some sort of transformation on that data and load it directly into a data warehouse. So it is possible to use a warehouse for your bronze layer, but if you want to keep a record of those incoming files, you want to be doing that in a lakehouse. We've talked about if you're ingesting streaming data, you might want to add a bronze KQL database to store that. It has a lot richer functionality for time series, analysis, and storage as well. Now in the silver and the gold layer of a medallion architecture, that can be either a lakehouse or a data warehouse, depending on, as we mentioned, like the skill sets in your team, your preferences, the types of workloads that you're going to be doing on it. And one of those workloads is around building and serving machine learning models. So if that's what you're going to be doing, any sort of data science workloads and modeling and experimentation, EDA, exploratory data analysis, that's best done from data in a lakehouse. So if you're going to be doing machine learning, data science, really you want your typically silver layer to be a lakehouse. Number 29 is, do you have requirements for row level security, object level security, or dynamic data masking, or column level security as well? Now, these features are typically really only required in that gold layer where you're serving it up to some semantic modeling. And so a typical pattern is to make your gold layer a data warehouse, because the data warehouse is the only object where you can do all of these features in Fabric, like your column level security, dynamic data masking. So as it gets closer to the business user, that's where you want to start controlling more rigorously who can access what. Next, we move on to building semantic models from your data. And again, I've linked to the video where I explain this in a lot more detail. We're going to be talking you through these quite quickly, but if you want more detail, then check out this video here. Now, there's 3 connection modes to choose from when you're connecting to data in Fabric to build semantic models. Now, we've still got the import mode and the direct query mode, and we've got the new option to create direct lake connection mode models. So I just wanted to talk about a few questions when designing and selecting a semantic model connection mode. So if you're going to be using views in your semantic model, SQL views from the data warehouse, then you're not going to be able to benefit from direct lake. So if you've got SQL views, then it's going to fall back to direct query mode. So just bear that in mind. Can I still use import mode? Well, you can technically, yes. And there's some scenarios where that might still be useful or a good decision. So if you don't need real-time updates on your data, which direct query and direct lake provide, if you don't really need that, then there's no reason why you shouldn't pick import mode. Or when you want to control over when that data refreshes. So in some instances, you might not want users to see real-time information. You might want them to only get data once per day or once per hour, for example. Another option where import mode might still be a good idea is that when your data size is really small, it can fit easily into a Power BI model, you can query it very easily. You're not talking like gigabytes and petabytes where some of the direct query and the direct lake mode become more useful. So if that's not a constraint that you have around data size, then again, that could be an option. Another question here is around, do you want to combine data from multiple data stores of the same type into one semantic model? So currently a direct lake model has to read from one data store. So if you want to use direct lake, you can only do that from one data warehouse, for example. Now you can, from Power BI Desktop, get data from different data stores, for example, one lakehouse and another lakehouse, or one warehouse, another warehouse. I think they have to be the same type, but you can do this using direct query and just going on get data, getting data from Fabric and selecting multiple. It's going to force you to use direct query, but I think it is possible. Next up, we want to talk about validating your data and your semantic models. A really, really important point that I think is worth going over again. So some of the questions that you might want to consider at this stage are, well, do you have a pre-existing data quality tool that you might want to use, and does it integrate with Fabric? So if you've already got a lot of data quality testing set up in some sort of third-party tool, then you want to check whether that integrates with Fabric. And if the answer to either of those questions is no, then you might want to look at some of the open source tooling that's available through the Python libraries, the Python frameworks like Great Expectations, because these can be accessible through Fabric notebooks. And I did a long video kind of looking at how you can integrate Great Expectations into Fabric notebooks to validate each of these different file types. Next, what skill sets do you have in your team? So if you've got predominantly SQL users, then you can build validation rules either directly in your warehouse using stored procedures, although that's maybe not recommended, or you can use third-party tools like dbt. If you've got Python developers, then you can use open source Python frameworks like Great Expectations, or Pydantic, for example, is another one, but I recommend Great Expectations because it allows you to do testing of all of these different data types, incoming files, tables, data frames, semantic models very easily, and it allows you to do kind of enterprise level data monitoring as well. Now, what are the most important data sets and columns within those data sets in your organization, and how can you validate them? Okay, i.e., if there's a problem X with column Y in dataset Z, my reporting / analytics or machine learning is going to be impacted. So here we're getting a bit more fine grained. You need to think about, what are the really important data sets in my organization? And within those data sets, what are the really important columns? Okay, so what are the columns that have a big impact on my downstream analytics? Maybe I'm building a whole report based on this date column. Okay, it's like a time series analysis. And so if that date column is of poor quality, then that's going to really impact the validity of my outcomes in my analysis. So how are we going to validate that? What are the different ways in which that column could potentially go wrong? And how can I build tests to make sure that that column is always of good quality? Do you want to monitor data quality across all data sets in your organization? So we've talked in the video previously about enterprise-wide monitoring of data quality. And for that, I definitely recommend you use Great Expectations. If you're going to look towards open source technologies, definitely recommend Great Expectations. So that was it. Thank you very much for reading. I hope that wasn't a too long video. We've gone through 36 questions to help you design data infrastructure, end-to-end solutions in Microsoft Fabric. If you found this useful, please write a comment on the YouTube video, because it definitely helps more people find the video and helps the word get out there. If you've got Power BI developers or people in your organization that are making these decisions about building and designing end-to-end infrastructure in Fabric, make sure you share it with them. Now, I do have one more video in this series. In the next video, I'm going to be taking a step back from the kind of more technical elements of the transition from Power BI to Microsoft Fabric, and I want to get a bit more personal. So specifically for you, sitting at home, you're thinking about your career options over the next few years. Maybe you're a Power BI developer now, but now you have a whole new world to kind of explore and step into potentially if you want to. And I'm someone that has kind of made that journey myself. About 6 or 7 years ago, I moved from building Power BI reports to focusing more on data science and data engineering, and data architecture. So I do have a few comments that might be valuable to you if you're thinking about moving from being a Power BI developer personally in your own career to some of the roles that exist within the Fabric ecosystem and the Fabric environment. Thank you very much for watching. I'll see you in the next video. Hey everyone, and welcome back to the channel. In today's video, we've got something a little bit different for you. Now, to finish off this series, what I'm going to be doing is stepping away from the technical side of Fabric, understanding about pipelines and lakehouses and all this kind of stuff. And really I want to focus on you and what Fabric could mean for your career. Now, I think it's normal for a lot of people out there, especially Power BI developers, to look at the news around Fabric, start learning about Fabric, and then suddenly think, this could really represent a bit of a change in direction for my career. A lot of the world of data engineering, data science, analytics engineering suddenly becomes a lot more accessible. So you've got a lot of ideas around, should I be focusing on this for the next few years in my career? So in this video, we're going to go through a few things. We're going to start by looking at some of the options available to you in a Fabric world in terms of your career. We're going to talk about why I think that could be a beneficial move for you. And we're also going to talk about some of the mindset shifts that you might have to go through, some things that you might have to think about differently when you're moving into different roles like analytics engineering, data science. Now, this is a topic I'm particularly passionate about because this is a transition that I made in my own career. So about 6 or 7 years ago, I was building Power BI reports within a company, and then I moved more into data science roles and more recently data engineering, data strategy roles. So this is something I've got a lot of views on, and hopefully I can kind of share some of the lessons learned and hope that it helps you make good decisions over what you're going to be doing in the next few years of your career. So let's get into it. So to kick us off, I wanted to go through some of the options that are available to you. So the first option really is to continue what you're doing with Power BI. Like if you love building reports and you're happy with that, that's absolutely fine. I'm not going to stop you from doing that. That's absolutely great. Now, I do think it will still be very beneficial for you, even if you want to continue down that Power BI report development route, to learn more about Fabric. Because in the future, I believe that a lot of the reports that you're going to be building is going to be built from data in Fabric. As more and more companies migrate over, they start doing a lot of their storage and modeling inside Fabric. It's really going to help you in your career if you know more about Fabric. And I think the more you learn about Fabric, the more valuable it's going to make you as a Power BI developer. For example, if you can take control over, creating SQL views in a data warehouse, for example, molding the data that you need for your reports on your own, if you can take some of that autonomy, it's definitely going to help out your company and it's going to make you a lot more valuable. Take the pressure off data engineering teams, takes the pressure off analytics engineers, and it makes you a more valuable employee for your company if you can do more of that work yourself. And one thing to bear in mind is that Power BI is a very powerful tool. It's kind of like an all-in-one Swiss Army knife. It can do lots of different things, right? You can do data ingestion, data transformation, modeling, and data visualization all in one tool. And that's absolutely fantastic. But just because you can do something in one tool doesn't necessarily mean that it's the best place to do these things. With the introduction of Fabric, a lot of that data ingestion, data storage, data transformation piece is going to be moved upstream, right? You probably heard of Roche's maxim of data transformation. Data should be transformed as far upstream as possible and as far downstream as necessary, right? And what that means in a Fabric world really is that a lot of the ingestion, transformation stuff is likely going to be done in Microsoft Fabric. And for me anyway, I see the future of Power BI being a lot more focused just around the visualization piece, semantic modeling, defining relationships, anything that you have to do in Power BI, like filter context and that kind of stuff. That's where I think the future of Power BI will be. A lot of the transformation, cleaning, all of that stuff should be done in Fabric. And this has the benefit that your data sets can be validated, your data set can be shared more easily. They're not just confined to one semantic model. You're kind of building enterprise data assets that you can share amongst your teams more easily. So if you do want to continue down this route of developing Power BI dashboards and reports, absolutely go for it. I think it will still be worth your while to learn little bits of Fabric as much as you feel comfortable with. So if you're a little bit bored of just churning out reports, you could shift into analytics engineering. So what is analytics engineering? Well, the way that I kind of think about it is if you're a Power BI developer, your product is your report, right? That's the thing that you're building and you're focusing on, building beautiful reports. And the end user is your business user, right? The consumer of that report. Well, in analytics engineering, that focus shifts, right? Your data becomes the product itself, and your users are the people that are going to consume that data. So it could be the Power BI developers, could be data scientists, data analysts, anyone that needs like high quality data. And when you make data the product itself, really you have to shift focus in your mindset really. You need to think about how you can deliver high quality data that's complete, that's validated, timely, well modeled, and also documented as well. And these are all slightly different things to what you think about when you're building a Power BI report. Could mean things like source controlling your ETL jobs, could be testing your code, validating your data, segregating different development, test and production workloads and data so that you're really sure that you're delivering a high quality product at the end of each pipeline, right? Your product being the data. Ultimately, your goal is to build robust pipelines that reliably produce high quality data sets that can easily be consumed by the user. Now, personally, I find this work a lot more interesting, and I would definitely argue that it's a more valuable skill in businesses because businesses are crying out for high quality data. I think we've gone through the phase of BI where it's nice to just build lots of reports. Now I see the big kind of industry shift towards the demand for high quality, tested, validated data sets on which you can build your reporting, your machine learning models, all that kind of stuff more downstream. The focus in investment and the focus in data strategies becomes how do we make sure that our data sets are of really high quality by the time they reach that gold layer. Now, if becoming an analytics engineer is the goal for your career, then a good obvious first target is the DP600 exam to become a certified Fabric analytics engineer. It's going to introduce you to a lot of new technologies, ways of thinking, ways of working, and it covers quite a wide range of the Fabric technologies, right? Lakehouses, data warehouses, pipelines, data flows, all of these things and how we can use them together, Git integration, advanced semantic modeling, building large models and that kind of thing as well. So I definitely recommend, if that's your goal, that's a really good first step to you to learn what it takes to pass that exam. And on this channel, in the future, in the next few weeks, I'm going to be starting producing more content specifically around DP600 to help you pass that exam. So watch out for the announcements. If you're not subscribed already, then make sure you are subscribed to get these videos when they launch. So next up, we have the option to become a data engineer. Now, the distinction between a data engineer and an analytics engineer, those lines are quite blurry. and they can mean different things to different organizations. So I don't want to get too hung up on the syntax, the terminology, but for me, a data engineer is doing a lot more work in Spark in the data engineering experience, right? So they're probably going to be better Python programmers. They're going to be doing more of the complex transformations, working more around parameterization and automation, right? So how can you do ETL jobs across all of the tables in your bronze layer, for example, working out how to parse really thorny like JSON structures, doing a lot of more complex stuff, as well as more like system optimization. How do we make sure that this engineering system as a whole is working reliably? So things like setting up testing for your code, making sure that that whole data pipeline is robust. Now, as well as that, I would expect data engineers to be really proficient in the data warehouse, know how to set up a data warehouse, structure a data warehouse, set up a lakehouse, optimize a lakehouse, and kind of the underlying delta tables as well. So they're a little bit more technical, a bit more advanced skill set. So if this is your goal, then a good route into that, I would say, is via the analytics engineering route. Now, next up, we got the data scientist. So a lot of you might want to move into data science. You want to be building machine learning models that predict things about your data in your organization, right? So the distinction here really, for me at least anyway, is data science are focused a lot more around what's going to happen in the future. So Power BI developer, you're doing more descriptive analysis about what's happened in the past. Data scientist is looking about what's going to happen in the future. What's your revenue of your company going to be? What's going to impact your revenue in the future? Those kind of problems. And they're actually really interesting problems. And I worked as a data scientist in 2 companies and I absolutely loved it. What I would say is for people that want to transition from kind of Power BI to data science is that it's going to be a bit more challenging. There's a lot more skills that you have to learn. You have to learn about the data science process. You have to learn programming to quite a good level in Python or R. I'd recommend Python. And alongside the programming side of things, you're also going to have to learn about a lot more theory around machine learning models. How do they work? How do you choose the right ones for different scenarios, depending on your data and your problem? But the one thing you have as a Power BI developer, or at least hopefully, is a really good understanding of the business, right? So the data scientist is a lot more business focused most of the time. So you're solving problems for the business, and often you're communicating your results to people in the business as well. So your skills as a Power BI developer in that respect are going to be quite transferable and useful, right? So if you've got experience presenting a dashboard to the business and kind of selling that idea, selling your analysis to the business, that's going to be a really useful skill if you want to move into data science. But there is going to be quite a few steps for you to make to become kind of a useful data scientist, I would argue. Now, for me, how I did that was I did a master's degree in data science, took 2 years part-time. So that's where I built up a lot of the theoretical knowledge and also practical knowledge of how to implement data science and do data science in a business. Now, one thing I would say is that if this is your goal, then I would argue it's still beneficial to go through the route of analytics engineering, because what I find is that a lot of data scientists, especially in kind of the early career data scientists, a lot of your work is going to be similar or more similar to data engineering or analytics engineering, right? You're going to have to learn how to clean data sets very effectively, very quickly, building some sort of data infrastructure. And so from my experience, at least, the role of the data scientist, especially in smaller companies, can actually look a lot more similar to a data engineer, right? Because if you don't have a team of data engineers to help you productionize your code or build views and extract data from databases, you're going to have to learn all these skills anyway, right? So it helps to be really good at SQL to get some data in a format, or to be really good at Python to learn how to clean data, transform data, model the data that you need in the shape that you need it to do some sort of machine learning, some sort of predictive analysis. So if your goal is to be a data scientist, just be aware that there's quite a few steps you need to go through. And I think it's still worthwhile for you to go through the route of analytics engineering, data engineering, learn those skills first, because they're going to be really valuable if you then decide to go into a role in data science. So that's some of the options that are available to you in the world of Fabric. There's probably a lot more. These are just some of the main ones that I wanted to touch on. Now, one thing that I think not many people understand or think about when they're making this kind of transition or thinking about whether it's the right thing for them, and I think it's really important, is that Fabric is built on top of technologies that are very, very widely used in the industry, right? So you're talking T-SQL, Python, Spark, Delta. All of these things are very, very transferable skills. A lot more, I would argue, than the skills that you're building up in the world of Power BI. So this opens up a lot of options to you in your career. And learning these technologies is actually quite painful, right? So you need to choose your pain wisely, I would argue. So for me, it makes a lot more sense to direct your energy, your learning energy, into the technologies that are going to give you the biggest leverage in your career. So for me, those are things like T-SQL and Python, because every company uses T-SQL and Python. And by going really deep on technologies like DAX and Power Query in the Power BI world, that's great if you want to spend your career working in Power BI. But if you invest that time and the energy into learning things like SQL and Python, that's going to open up a huge amount of opportunities to you, because every company uses these technologies. So let's just round up this video with a few next steps for you. I would argue that a good first step for anyone really is to get a thorough understanding of analytics engineering and how that works in Microsoft Fabric. So understanding more about that engineering mindset, because it underpins a lot of the other roles, right? If you want to become a data engineer, a data scientist, a lot of these things, the technologies and the skill sets that you build up in the role of an analytics engineer, they're going to be really, really useful. So how do you get going as an analytics engineer? Well, we've already mentioned it. I think a really good target for you is the DP600 certification. Might require you to learn quite a lot of new technologies, new skills, but it gives you focus in your learning. Now, that's not to say that if you become a certified Fabric analytics engineer, that's the pinnacle of your career. Now you can rest and relax. No, for me, it's a bit like passing your driving test, right? It shows that you're competent enough to be trusted to do certain things. But a lot of people say that once you've got your certification, that's when you really start to learn the technology and how to actually apply it in the real world. So that would be my initial focus if I was working in Power BI today, because it's very adjacent in terms of skill set, right? So you can leverage a lot of the knowledge you already have in terms of semantic modeling. I think semantic modeling is about 25% of that exam. 75% might be new stuff, but it's definitely worthwhile learning that. The final point I want to make is around how you can become valuable very quickly, because you might have built up a lot of skills in the world of Power BI, but then if you want to transition into the world of Fabric, really you need to learn how to provide value to your company very quickly, right? Because you might be starting at a lower level in the world of analytics engineering because it's quite new to you. And the best route that I see for Power BI developers to become valuable in the world of Fabric, if you want to become an analytics engineer, is to focus really on a few technologies and learn them really, really well. Fabric is a really vast platform and it can be easy to get overwhelmed. You've got real-time analytics, data science, data engineering, data warehousing. And so you really need to focus on the areas that are going to give you the most value as quickly as possible. And for me, as an analytics engineer, I would be focusing on the data factory experience. So really learning data flows, which hopefully you know pretty well already if you're a Power BI developer, and data pipelines. So these are kind of the two orchestration, ETL tools that are used right across the data stack. And so it would be really worthwhile learning how to get really good at these. Now, I used to interview quite a few people at my last job, and I was actually surprised how many people have full-time jobs just creating, managing, and maintaining ADF pipelines, Azure Data Factory pipelines. So it can be your full-time job in some companies just to focus on the data pipelines part. And it's quite a simple tool, but there's layers and layers of complexity. So it's easy to get started, but then there's a lot of complexities and strategies for building more complex pipelines that you can learn in time. But I think it's a really good place to focus your energy. As well as the data factory experience, I would definitely recommend really understanding the data warehouse. So this is more than likely going to be your gold layer in a company. So it's the nearest really to the world of Power BI. So here you're going to be able to transfer a lot of the skills that you built up in modeling, building star schemas, doing all that kind of stuff. But you're just going to be doing it in slightly different technologies, right? So you're going to have to learn how to apply what you've learnt in Power BI to a different technology stack, to the world of SQL, right? How can you produce that stuff using SQL views, SQL tables, stored procedures, all of that kind of stuff. And SQL is a really, really valuable skill set for you to learn, and it will make you employable by basically any company in the world that does data, not just those that use Power BI. So I definitely recommend that as an area to focus on. Thank you very much for watching. That's all we've got time for today. And I hope you found that valuable, my kind of ranting on different career options for you. Let me know if you are considering a career in Microsoft Fabric, which of these different options are most interesting to you. This is the last video in the series where I have been helping you transition from the world of Power BI to the world of Microsoft Fabric. Thank you so much for joining me. I hope you found the content really valuable, and if you have, I would be really, really grateful if you can leave a like, let me know in the comments, share the series, the playlist with people in your organization that you think might find it valuable. Thank you so much for watching, and I'll see you on the channel soon.